Howdy, howdy, everybody. Hope everybody's having a good day. Do. I'm back. Good morning indeed. Is it a good morning though? Could be. It rained and then dirted on my telescope last night, which is kind of a bummer. Are you a vegan? I'm not. Pale lobster god? No, we have a lava lamp. There's a flurf on the Discord who wants to debate on the next flurf day. Well, he can come up the next flurf day. Who knows when that'll be? Yeah, sometimes in Arizona, rather than raining, it dirts. Joseph Moleski, if you want to come up and debate the topic, you're welcome to do so. There's a Discord link. You can join on TikTok. You're welcome to do so. Elon is indeed anti-science, yes. All right, well, we do have our first guest. Let's just gotta open up my notepad really quick so then we can refer to the right person. What's today? Today is the 6th. Sule, how's it going? Oh, okay, they did not want to be here. That is fine, you don't have to be here. It's not a requirement. Andy, you say that you're from Vietnam. I am looking to talk to Americans. Because this is an American topic. Would you do an IRL physicist like you're doing IRL atheist debates? Well, people don't show up for Ask a Physicist, right? That's the trouble. How is MAGA anti-science? Well, look, so you can look at either the people or the policies. The people, you can just look at polling data, and what you'll find is that on politically inconvenient topics, conservatives generally or Republicans generally and MAGA more specifically tend to disagree with the scientific consensus when that scientific consensus is inconvenient. On the subject of policy, we see tons of executive actions and three-letter agencies that have taken basically punitive actions, or not even punitive actions, like punitive implies that they're punishing them for something, just kind of attacks on scientific institutions because they're politically they lean politically in the other direction, and this is harming our scientific inquiry. Also, you have the executive branch shutting down scientific instruments, scientific organizations, scientific labs that produce science, that produce research that's politically inconvenient. So feel bad for you claiming you have a PhD, but here you are doing TikTok live. Oh, my PhD is like, my diploma is just like down there. I can get it if you want, but you'd have to come up first. Elon is anti-science has to be the most disqualifying comment I've ever heard. Well, feel free to come up and defend it, Lemon Don, but unfortunately for you, Elon Musk was the head of Doge, and Doge is responsible for canceling billions of dollars worth of grants that were canceled for political reasons rather than scientific ones. But they would never defend, but you would never come up and defend that because you know that you can't. Is Trump right in being against wind power? No, he's crazy. We are live. Yeah. We're just waiting for a guest, a brave MAGA soul. Didn't Trump make it to where funding for science is approved by the government instead of peers? Indeed. At least that was on the table. I don't actually know if it passed. Let's find out. This is from the OMB, which is a White House office. I want updates on this. Okay, so it hasn't come into effect yet, but it was proposed by the OMB, so. And I guess that it's still being fought over. Why is my mouth always delayed? Who knows? We're not MAGA, my friend? Well, if you're not MAGA, then I don't know who we're talking about, right? But it seems like all of the MAGA types, all of the right-wing Trump supporter types, just they're a little bit afraid to come up and defend their view, or maybe they recognize that it's anti-science, and then, you know, they just don't care. Let's bring up helping. Helping, how's it going?
Hi, I'm from Sweden, so I'm not really in opposition. I just have to ask, do you genuinely think that a person that ascribes themselves as MAGA would ever openly discuss science?
They try to all the time, yeah. They fail, but they try to all the time.
I've
Go look
noticed,
at the comments.
Yeah, I can read them. I see this so often, especially this type of, I don't know what to call you, rage baiting, but you kind of have to rage bait them so they do actually
Well,
join
they're emotionally insecure and underdeveloped, so like it works quite frequently.
And
so
what's the goal with this? Is this to spread, like,
so there are some people who are like conservative and are like loosely MAGA, and they consider themselves pro-science. Like these are like, think like kind of non-political tech bros, and they just don't know about all of the horrible things that the Trump administration and MAGA more broadly has done for like scientific development. And those people can actually often be kind of swayed a little bit. As for like the Trumpers, the trumpets, those people are just fun to make fun of, and it's good to see, and it's good to show other people how bad they look.
Okay, yeah, okay, I see.
Hopefully that helps.
Keep it up. I really enjoyed the stream.
All right, take care.
Good luck.
Thanks. Does anyone care about Sweden's politics? Probably not. Oh, FFS. Here we go. TDS cucks crying like little bitches. Viper, if you want to come up and defend your God King, you're welcome to do so. But it just seems like that you're probably not going to be able to. Do you think it's a government responsibility to control the trajectory of science? Is it a government responsibility? Maybe. I mean, in some sense, the government is charged with promoting the public good, and science is known to do that. So, I mean, you could potentially justify it that way, but the question is not whether it's the government's responsibility. The fact of the matter is that historically it has been. Or the question is not whether it should be the government's responsibility. The question is whether it has been, and historically it has been. This is why the United States has been so successful in scientific inquiry in the last 70 years. And that's currently being dismantled by the Trump administration. So, all right, we have a £2 super chat from Matt Lloyd. Hi, Dr. Blitz. Hope you have a good stream. Well, I hope so too. But the MAGA types seem to be very afraid today. So we might just have to yap until they decide to show their the itty bitty little feet. Free, why are you asking me about? Free De La Hoya, I'm not going to tell you how to convince your dad to let you grow out your hair using physics.
Dang it, dude.
Let's talk to Michaelis. Michaelis? They seem to run away the moment I bring them up.
Oh, play Farm Sim, please. Can you play Farming Simulator?
No.
It's a brilliant game.
May I ask what sector of science you contribute to? I'm a physicist. No, I know they're here in the chat. They're just too afraid to join up. That's the problem, I guess. But that's fine. I mean, if they're too afraid, that's totally okay. I could just make fun of other people, like flat earthers, but you know, honestly, it'd be the same people. Let's bring up Shane. Shane, how's it going?
It's going. How are you?
I'm doing all right. Shane, are you MAGA?
No.
Why'd you join?
Do you want to hear a joke about a ghost?
No. What a weird thing. All right, we have another guest. Elliot, how's it going? Elliot ran away too. Let's talk to Bamboo Shoot. Bamboo Shoot, how's it going?
When did you last shit? When did you last
Is
shit?
this what it's like to be Dean and Parker? Gotta get all the trolls out of the way before we get started. James, how's it going?
Hey man, how are you?
I'm doing all right. James, are you MAGA?
I'm not American, to be honest.
Okay, well, why'd you join then?
But I have opinions about that topic.
Right, but unfortunately, and I say this with as much love as I can, your opinions about MAGA mean nothing.
But I
Because
do believe
your
that
votes, your opinions can't influence anything that's happening in the country that I live in. So,
Okay, that's all good.
so I'm gonna let you go, James, but thanks for being here. With as much love as possible. Like, it just doesn't matter, right? Yeah, usually I don't get as many trolls, but I guess maybe Dean and Parker aren't live yet, so somebody's just looking for people are looking for streamers to go bother. That's possible. Yeah, Dean and Parker aren't live, so that could be it. Dean or Parker. It's the topic. Well, maybe. From Matt Lloyd with the £2 again. What's up with everyone today? Who knows? Who knows, man? It's hard to say. Maggots are indeed afraid of science. Yeah, I mean, like, look, there's a lot of people who are very loud in the comments. Like, we have Troy here who's saying, when you say anti-science, are you saying anti-Dr. Anthony Fauci? Like, you could come up and you could talk. This is a normal thing. But if you're too afraid to come up and talk, then that's totally normal. I get it. I'm an intimidating guy. I'm 8'4". As wide as a barn. I feel like that's like the beginning of a Disney song or something. We in Europe just laugh with the land of the free. Yeah, I know, it's so sad. Oh, when I'm talking, I'm echoing bad? Am I really echoing badly? No echo? Okay, it might just be on your end. In what respect are they anti-science? Both in the general large-scale beliefs of the population. Oh, actually, I'll answer that question in a minute. We have some guests. We got to prioritize the guests because they're here and we don't want to waste their time. JP29A, how's it going?
Hey, I'm good. How are you?
I'm doing A-okay. What should I call you? Do you prefer 29?
JP's fine, yeah.
Okay, JP, are you MAGA?
I was MAGA in 2016. I'm not anymore. I was somewhat involved with Trump's repealing of the endangerment finding for CO2. A colleague of mine.
Before?
I think briefly, like last week or something.
Okay. So look, I mean, you're not MAGA anymore, which kudos, I'm proud of you. But why should we, like, what do we disagree on?
I think on the climate change thing, I was part of. I agree with Trump's repealing of the CO2 endangerment finding, and I was part, I think, of Trump's. I influenced Trump partly in doing that because I worked with some colleagues who went and visited Trump in early 2016 when he first became president to advise him on the science of climate change, which subsequently led to the repeal, eventually, of
do
the
you think that was a good thing?
endangerment finding. Yeah, exactly. Yeah, I do. Yeah, CO2 is not a danger. Not a danger.
Well, it's not a poison, but it is a greenhouse gas. Surely we agree on that.
No, there's no such thing as the greenhouse effect.
How do you think greenhouses work?
Real greenhouses work by stopping convection.
Stopping convection won't be able to make it hotter inside than it is outside.
That's precisely how a real greenhouse effect works. Yeah, that's exactly what a real greenhouse effect does. It stops convection, and that makes it warmer inside the greenhouse than outside.
Convection isn't the only way to cool something off, to be clear.
That's the way the open atmosphere cools, though, is with convection. And you stop that process with a glass greenhouse, which allows the sunlight to still warm the inside, but then the inside air is trapped there and cannot convect and cool. And so that warm air just stays trapped inside the greenhouse.
So
because
maybe
sunlight
we can
is
just double
actually
check.
quite hot.
How do you understand sunlight doesn't have a temperature, right? It's not an equilibrium system, but
it causes heating.
That's neither here nor
Sunlight
there.
transfers heat.
Maybe you can tell me what your understanding of the greenhouse effect is and why you think it's not real.
Yeah, can you pull up a diagram of the greenhouse effect, a schematic? I have a tiny URL for you if you want.
Want me to just show you a CO2 absorption spectrum? I can show you that.
No, I know what those are. I'd like you to look at a tiny URL if you want of the diagram of the
I'm not
greenhouse
going to
effect.
click on some random tiny URL. I would just like you to describe to me what you think the greenhouse effect is.
Well, there's the real greenhouse effect, which I explained is the
explain to me what you think the greenhouse effect that we learn in school is, and then you can tell me why you think it's wrong. Does that make sense?
Of the climate science version of the greenhouse effect.
The kind that involves radiation. Can you tell me about that?
Right. Yeah. Yeah.
What do you think it is?
Well, that postulates that sunlight comes in, heats the inside a little bit, but then the radiation is trapped inside and bounces around and heats up some more.
Well, it doesn't heat up some more. It just doesn't leave. Does that make sense?
Yeah, that's the theory. Yeah.
Yeah. Okay. So what's wrong with
that? Thermal radiation is spontaneous. As soon as the surface of the so as soon as the surface of the greenhouse building, the glass, attains its temperature, it has to emit. So it can't actually get hotter than the radiation coming in.
So just to be clear, you understand that sunlight, most of the sunlight anyway, is going to will pass through glass, right?
Yeah.
Glass is transparent. So that sunlight will instead dump its energy on the ground or on the stuff inside the greenhouse, say, right?
It doesn't instead do that. It always does that. Does that on the open ground too.
Well, no, I mean, if it wasn't glass, if there was like steel, then it would reflect off, right?
Well, of course, yeah, sure. Yeah.
Right, so the point is that the sunlight passes through the glass because it's in the visible part of the spectrum, at least most of it, and then it dumps its energy into the stuff inside when it lands on it. Some of it will reflect off, of course, but the stuff that doesn't reflect off will be absorbed and will heat up the system. Now, as the system gets warmer, it radiates. This is in agreement with what you said. And the radiation, the part of the spectrum that it radiates in depends on its temperature. We agree on that so far? Okay.
Of course,
so now for things that are not above a few thousand degrees, the radiation that emitted will be in the infrared part of the spectrum or perhaps the microwave part of the spectrum if they're particularly cold, right? Okay. Now, that radiation goes in all directions. So the question is so obviously some of it will go into the other parts of the thing inside this glass building. Some of it will go back up to the sky, right? Now, if the glass wasn't there, well, that radiation would just go up into the sky. It would leave. However, glass absorbs, depending on what kind of glass, of course, and depending on the wavelength. Glass is generally going to be less transparent to infrared than it is to visible light. Can we agree on that?
Yeah.
Okay, so do we agree then that placing a greenhouse, placing a glass barrier, say, over some region, will prevent heat leakage in the form of thermal radiation from the system?
No.
Okay, which step didn't make sense to you?
Heat because thermal emission is spontaneous. So as soon as the glass attains the temperature, the glass then emits that energy.
It emits it in both directions, though. That's the point.
So what happens is
So
the
it emits
downward
it back.
radiation
So
causes
there's an equilibrium that's reached, right? So it will emit some energy upwards, but it'll also just emit more downwards. So less will make it out.
No, not less, because it emits at the
Yes,
temperature
less.
at which it is.
No,
It
I mean
emits at
yes,
the
less,
temperature.
because
Both sides emit. Both sides emit at the temperature at which they're at. They don't
Yeah.
emit half. They emit
Yeah.
fully at the temperature at which
No,
they're at.
but
So
there's
what is
a
the
certain amount of
interior
energy.
radiation
Look,
going to do?
so
So
there's
the
a certain amount
radiation
of
on the inside from the ceiling
there's a
pointing
certain
down,
amount
what
of
does it do?
energy.
Can it cause further heating?
Let me explain. There's a certain amount of energy.
It can't cause
that,
further heating, can it?
Do you want me to explain why is that half?
Well, you can try.
Okay, yeah. So there's a certain amount of energy that's being, like, we can just think of this as a conserved energy system for in the case of the glass. There's a certain amount of energy that's being absorbed by the glass from the radiation from inside the greenhouse, right? We can just call it a greenhouse. Of course, some will also be absorbed from the sky, but the energy source that we're looking at here is really from the greenhouse, because most of the energy from the sky is going to be visible, right? Anyway, so a certain amount of energy comes from the greenhouse, gets absorbed by the glass. Now, in order for that glass to reach an equilibrium temperature, it has to radiate away exactly as much energy as it absorbs. That's when it stabilizes, right? Yeah. Now, the thing is all of the energy that has to radiate away, that's going to come from the energy input, right? Otherwise, it's not going to be at equilibrium. It'll either be radiating away too much or radiating away not enough. So that means that all of the energy coming from the inside is broken up, split in two. Half of it will radiate away to the outside, and the other half will go back inside.
No, any surface emits at its temperature.
Yes,
the interior
but the amount that they
doesn't leave
emit,
the system.
the amount that they emit depends on the surface area. Do you understand that?
The energy emitted inside doesn't leave the system. The outside of the system emits at its temperature. So the exterior of the glass, which has attained its temperature in equilibrium with the sunlight, will emit fully
The
all of the
sunlight doesn't have
radiation
a
it needs to
temperature.
in equilibrium with its flux. I'm saying it's the equivalent flux.
So
I'm talking about the Stefan-Boltzmann law. You know, I'm simply equating.
I
flux
know.
with
I know we're
temperature
talking about the
with
Stefan-Boltzmann law. The point is, so we agree that there will be an equilibrium temperature, right? There will be an equilibrium temperature at which the glass radiates.
What's the equilibrium set by?
It's set by the surface area, the emissivity, the frequency of the absorbed radiation, and the frequency of the emitted radiation. And did I already say temperature? It's the Stefan-Boltzmann. I have a PhD in physics. You're not gonna catch me up on thermodynamics here. Anyway.
Well, it's pretty easy. You can just say the equilibrium is set by the input. The input has to equal the output. It's really simple, actually.
Well, yeah. So obviously.
So the output has to equal the input.
I was literally telling you that like 3 minutes ago, and it sounded like you disagreed. So the point is that a piece of glass.
Because you're throwing in a factor of half here for some reason.
Right. That factor of half is because
the glass doesn't know to emit by half. It emits
I'm not
fully
saying it's
at its
emitting by
temperature.
half. It emits half of its radiation in one direction, half of its radiation in the other direction, because it's emitting on all of the available from all of the available surface areas.
Thick. The exterior surface of the glass emits fully at the temperature at its at.
That's a nonsense. That's a nonsense statement. The amount of power emitted is proportional. The amount of power emitted is proportional to the surface area. So if you just have the top surface area.
Talk in terms of flux, so that we can talk in terms of temperature, equivalent temperature via the Stefan-Boltzmann law, flux and temperature.
We don't need to talk in terms of flux. The Stefan-Boltzmann law involves temperature, emissivity, the Stefan-Boltzmann constant, surface area. That's what the Stefan-Boltzmann law is about.
No, you're wrong.
Yeah, it's sigma epsilon AT to the fourth.
What's the units of flux? The joules per second per meter per square meter.
Yeah.
So it's not multiplied. It's not multiplying surface area. It's not total surface area.
The Stefan-Boltzmann law is P equals sigma epsilon AT to the fourth. I don't know what Stefan-Boltzmann law you're using. I guess you could write it in terms of flux if you want to. You could divide through by A if you wanted, and then you could get power. Then you could get power per area, which would be a flux.
It is divided by area. That's what the Stefan-Boltzmann.
You can multiply through by area, and then you just have total emitted power.
Right.
Is that confusing?
No, it's not confusing. It seems to be confusing to you. In any case, so the input has to equal the output, right? So the input energy from the sun.
Do I need to draw a diagram? I feel like I need to draw a diagram.
The absorbed input from the sun, right, has to equal the output from the glass, right? And what is the glass going to emit?
No, you're missing another input. There's the input radiation from the stuff inside the greenhouse.
the stuff inside the greenhouse is passive. It's not producing any new heat or any new
Wait,
radiation.
of course it does.
Downstream.
It emits thermally.
Yeah, but it's not new input to the system. It's downstream.
We're okay. Hold on, I have to draw a diagram because I think that you're struggling here.
Well, I'm looking at a diagram here, and it shows the greenhouse effect diagram, and it shows that 240 watts per meter squared of solar input can be turned into.
So let's look.
What is it?
Find a good diagram.
340 watts per square meter inside the greenhouse.
I wasn't paying attention to what you were saying. Do you want to say it again?
Yeah, I'm looking at a diagram of the greenhouse effect here.
Mm-hmm.
That's right, and it shows that 240 watts per square meter solar input is turned into what's the equivalent? 340 watts per square meter of radiation inside the greenhouse.
I don't know what diagram you're looking at.
These are basic diagrams. If you follow the tiny URL I can give you, then you can look at it. It's a diagram of the greenhouse effect.
Can you tell me the name of the website? Because I'd rather not click on a tiny URL.
Yeah, sure. It's it's my own website, and it's just a diagram I have.
Why would you put a diagram on your own website if it's the diagram has wrong math?
It's from Harvard University,
Okay,
so I don't have the
Harvard link.
I don't have the source for that
Okay.
anymore. It's years old.
Okay, so you don't have the original source. You're just claiming that it's from Harvard. Okay, so then we can just draw a diagram together.
I mean, I have it documented somewhere. I can't come with it. Don't want to come up with it.
So we'll draw a diagram together. How about that? And then we can just that way then we're not talking past each other. Yeah.
All right. How do I see your diagram?
I'm sharing my screen right now. I just have to share it to everybody else.
On the Discord app?
Yeah. I haven't
Will
drawn
it come
it yet.
up on my phone?
Yeah, it should. You should be able to. There should it says live or something. You should be able to see it. You should be able to see MS Paint. Can you see it now?
I see nothing yet. I just see our voice interface.
Okay. Well, see how on the voice chat there's a thing that says live next to my name.
No, I don't see that.
Do you see where it says Blitz PhD's VC, where your name is?
Yeah, I see that.
Okay, now you should see two names under it, my name and yours.
Oh, there we go. Okay, got it. Yeah,
okay.
Got it.
Right. Okay, so you can see the diagram now.
Yeah, got it. Yeah.
Okay, so this is obviously not to scale, but I'm just going to imagine that this gray thing is the stuff inside. Actually, I'll put we'll draw another line. The gray thing is going to be the greenhouse. This green stuff is just stuff inside the greenhouse, and then we'll have blue sky outside. Okay.
Why don't you make it horizontal? Why put it on an angle? Make it horizontal just so that we don't have to deal with angles.
Oh, I don't know. I guess it looked better this way. But okay, sure. Sure. Okay, so we have one line, two lines. There's our glass. And we'll put some green stuff here.
Just put a surface. It doesn't matter. It's just the floor.
And then we have sky, right? Okay.
Yeah.
So we have light coming in. So I'm gonna do some labeling now, if that's okay. I'm gonna use some big letters. So we have T. We should use black. Let's say that we have TG. It's a greenhouse temperature. And we're not going to make any assumptions about this. We'll just call this, like maybe they're the same, maybe they're different, whatever. One's the temperature of the stuff inside the greenhouse, the other's the temperature of the stuff outside the greenhouse. Maybe they're the same, maybe they're not. And we'll have the temperature of the glass, right? There we go. I'll put this over here. Okay, so the point is that there's two sources of energy coming in to the temperature of the glass. I'll just use red lines for this, or sorry, yellow lines for this. So we have sunlight coming in. Some of that sunlight is going to be directly absorbed. Some of that sunlight will make it through the glass, right? And then we're also going to have some reflections. Well, we'll use a different color perhaps. Some reflections coming out. That'll pass through. Some of those reflections will be absorbed.
Let's just do plain parallel model, and you can just do up and down.
Don't worry about the angles. We're not gonna. I'm not worrying about the angles because I'm not going to do. I'm not going to do transmission coefficients or anything. This is just to make the diagram make sense. So it looks like that those are reflections. Then we also have thermal emissions. Those thermal emissions from the stuff inside. Some of it will make it through. Some of it will be absorbed. Right? And there's also thermal emissions from the sky as well, but we can lump that into what's going on with the sun. So we have three sources of energy that you could break it up into three sources of energy. There's reflected light that's then absorbed. This is reflected visible light. This is energy that's entering to the glass, right? Being absorbed by the glass. We have direct sunlight that's being absorbed, and then we have thermal emissions that are being absorbed, right? Do we agree that we can group our energy sources in that way?
Yeah, roughly. Yeah, I mean, you can simplify. Just say input and absorbed, and then emitted output.
Yeah. Okay. But now this, depending on what kind of energy sources are coming in, you're going to end up at some equilibrium temperature from the stuff in Boltzmann law, right? This is going to radiate. I'm going to use another color. I'm going to draw squiggles for the radiation to indicate that it's output, I guess. So we have, I'll draw it over here. So we have radiation in all directions. It's not thick enough, sorry. How do I make you thicker? Just hard to see.
You're actually recreating the diagram that I wanted you to look at, by the way.
Why is it so thin?
It's okay, I can see it.
Okay, so we have radiation coming out in all directions. And, obviously it's everywhere. I'm just drawing it off to the side so it doesn't get too cluttered.
Of course.
Right. So we have three energy sources in. We have, in some sense, two energy sources coming out, the energy that's going up top, the energy that's going down below. It'll be an equal amount in both directions. So the total energy coming in, it doesn't actually, once it's been absorbed, it's not directional, right? And so if it's not directional, then the glass will emit equally upwards as it will downwards. Can we agree on that?
Sure, yeah.
Okay, so of the energy that makes it in, now I need a red circle. So we have this energy that's absorbed, this energy that's absorbed, and this energy that's absorbed. Where'd my marker go? All of that energy has to sum up to the total of this, right? Right?
Yeah, possibly. Let's see. Yeah, you got a lot of arrows there. It's simpler. It's better to simplify this and just have an input as, say, solar absorbed. With the albedo factor. So you just say input.
I think that this is pretty simple. Like I'm just drawing a picture here.
Yeah,
you have three energy sources in. I can even use a different color for the. Well,
there's only one real energy source in. The energy source in is only the sun.
That's the mistake that you're making, right?
I don't think it's a mistake. It's solar energy is absorbed in, and yes, there are details for how it gets absorbed, but it's not additional sources, right? Like everything downstream of the initial heating from the sun is downstream, right?
You can break it up, right?
Yeah, sure, yeah.
Okay,
yeah.
So
yeah, but you can't consider the secondary emissions to be additional sources. They're downstream sources, right?
I mean, they're coming from different things, so.
Yeah, but they're downstream. Like they cannot perform more heating than what has originally been deposited by the sunlight.
That's confused. Look. The point is that
that's not confused. The initial heat comes from the sun, and due to thermodynamics and everything like that, there's secondary emission after that initial heating from the sun cannot cause further temperature increase, right?
No. Point. It's not secondary things that are causing temperature increase. Look, you can just take like a single photon, for example. That photon will either be absorbed, in which case it'll fall into this bucket. It'll either pass through and be reflected, in which case it can either pass through or it can escape, in which case it'll either fall into this bucket or it will lose it, or it'll be absorbed by the ground, in which case another photon at some later time will be re-radiated, later time in terms of nanoseconds, by the way, will be re-radiated as thermal energy, which would be this source. And so the point is that how that initial photon's energy is distributed matters. Like where it ends up and where it comes from, like how that initial energy gets distributed, that matters. That matters for the problem here.
Well, it matters for what happens inside. But in any case, I'll let you finish.
We're interested in what happens inside. That's exactly it.
I'm just going to make the point that the input arrows have to equal the only 2 squiggly arrows you have going out. So that's what's equal. The input, the total absorbed input has to equal those 2 squiggly arrows out. No, whatever's happening inside doesn't leave the system. What's leaving the system is the 2 squiggly arrows pointing out.
We're only talking about the glass here. We're not talking about the greenhouse as a whole. We're talking about the glass.
I'm talking about law of conservation of energy. So whatever is input
I'm aware. You're
absorbed
confused.
has
We're
to
talking about the
balance
glass here.
with the 2 squiggly arrows pointing out, because that's going out. What's coming in has to balance what's going out.
Okay, so we're talking about the
squiggly
energy
arrows on the
input
inside
going
are
into
not
the
going
glass.
out.
Do you understand that we're talking about the
arrows? The squiggly arrows on the inside are not leaving the system. Well, you seem to not be listening.
I'm listening very closely. We're not talking about the system as a whole. We're not talking about all of this. We're talking about just the glass.
Well, we should, because I want to talk about the law of conservation of energy.
We will.
Because
we will. I promise we will.
Yeah.
But we have to understand this first, and it seems like you're struggling with this part.
Input needs to, so would you agree that input needs to equal output or not?
So input to the glass has to equal output from the glass. Do we agree on that?
We're talking about the whole system.
I'm talking about the glass specifically.
Well, yeah, the glass works too. It works for the glass too.
Okay, so let's just consider the glass for a second. Then we can get to the whole system, okay?
Yeah.
Okay, so if we just look at the glass, we're just looking at the energy conservation of the glass. The 3 input arrows to the glass, those have to equal the sum total of this plus this.
Right? No, the squiggly arrows going out only have to equal the total absorbed input.
The total absorbed input are the 3. So the total absorbed input are the 3 arrows, right? The total output radiation is these 4 arrows.
No, the output is only the 2 facing up. The interior arrows aren't leaving the system.
Those arrows are leaving the glass. They're leaving the glass.
They're not leaving the glass. They would be in equilibrium with the ground. They're in equilibrium with the ground.
No, they don't have to be in equilibrium with. They do. Well, they don't have to be in. I mean, in some sense, they have to be in equilibrium with the ground, but not in the temperature sense.
Well, that's what. Well, it's plane parallel, so they would be in this case.
No, not necessarily.
Depending on emissivity and absorptivity factors.
Right. There's a lot going in. But the point is
for simplicity.
The point is, no, you can't assume that. Like you can't just pretend that the only energy that's leaving the system is this energy. There's also the energy that's radiated downwards.
That's not leaving the system. That's trapped inside the system.
The system is the glass. The system is the glass.
It's in thermal equilibrium. It's not leaving.
You can't assume that. The system is the glass. We're trying to. We can maybe prove that it's in thermal equilibrium, but you can't assume that.
The whole system is not. The whole system is not the glass. The whole system is this whole object.
I'm not talking about the whole, like the everything inside the greenhouse. I'm talking just about the glass. I don't know what's so hard to get about that.
Sure. Well, those downward arrows aren't leaving the system. They're not leaving the glass.
Leaving the glass. They're leaving the glass.
In any case, what you need to look at is the exterior arrows, because those are what have to balance the input, because that's where energy is conserved, is to the exterior. Energy is conserved with the incoming solar.
Okay, you're confused. Right? It's fine. It's fine. You're confused. I get it. So look,
no, I think
if we're
you're
just
confused.
looking,
okay. Do you disagree that the solar input needs to be conserved with the energy leaving the glass back out to space?
So
that's the most obvious thing.
So it needs to be conserved in the long run. Energy has to be conserved. Power does not have to be conserved. And maybe that's actually the issue. Maybe you're confused about that. Power is not conserved.
We're talking about total energy. No, right, flux is not conserved. Flux is not conserved.
Nor is power. Power is not conserved. No, it's not.
No. Power is over time. Yeah, it's power
integrated over time is because that's what energy is.
Right. Right.
But I'm not talking. So we're currently talking about instantaneous energy deposition or power, like the rate at which energy is coming in. That's what we're really quantifying here, and that doesn't have to be conserved.
Well, we're talking about a thermal equilibrium system, so yeah, we do need to do it, and it's sufficiently simple with plane parallel model that it would be conserved over time.
So okay, so help me understand your understanding here, because maybe we're just talking past each other, and I would rather not do that. So we have this plane of glass, right? The plane of glass is absorbing energy in a few different ways. You could say that it's just absorbing energy, like however it's getting energy, wherever it's coming from, it's absorbing energy. It's absorbing thermal energy, it's absorbing visible light energy, perhaps it's conducting energy from the ground, whatever it is, right? It's absorbing energy in a few different ways. Do we agree that the energy that's leaving the glass, some of it will go upwards towards the sky and some of it will go downwards towards the ground?
Yeah, of course, yeah.
Okay.
It emits thermal emission will emit from both sides.
Right, okay. So if we're just talking about just the glass, trying to figure out the thermal equilibrium, or the equilibrium temperature of the glass, shouldn't we consider all of the radiation that it emits, not just the radiation in one direction?
We have to consider the radiation that leaves this system.
I'm just talking about the glass.
The radiation leaves the system from the glass.
I'm just talking about the no.
So the only
I'm just talking about how much radiation. I'm just talking about how much energy leaves
back out to space.
I'm just talking about how much energy leaves the glass.
That's what I just said as well. Did you not hear that?
No, you said the system.
The glass as the system.
Okay, so is the glass the system now?
Oh,
because
well,
you said
that's what you wanted to talk about.
Yeah. Okay.
We're talking about
we're just talking about the glass, right? Just talking about the glass. Yeah. Okay.
Okay.
If we're just talking about the glass, then the glass doesn't care what direction this stuff is emitted in. You have to account for all of the emitted energy.
Right.
Okay, so that means that you have to balance the input, which is these 3 arrows, with the output, which is these 4 arrows. If you're just talking about the equilibrium temperature of the glass, so neglecting conduction and convection, of course.
Okay, I don't know what you don't understand about the only play direction that the energy actually can leave.
Can you
the
address
system
what I said?
Space. I just did. I just used words to address it.
Okay.
Okay. Anyways, let's get
what you
past
were addressing
this
was asking a question, so you didn't.
So let's conclude.
Do you want to just do the math?
Conclude. No, I've done the math. I know the math. We don't need to. Let's take where this is going.
But okay.
So the conclusion of this is that the interior of the greenhouse is warmer than the incoming.
What? Why'd you cut yourself off?
You quit the live. Oh, you quit the live. Oh, I thought you kicked me out. You just quit the.
No, I was just closing the window since you didn't want to talk about it anymore.
Well, I liked looking at it anyway. It was still for reference. No, it was still reference because the point of that is.
Sorry, I can put it back up.
To show. It's fine, yeah. I mean, I have my own version on my computer screen here, but it was nice looking at yours. Anyway, so we can look at it together. But so what's the point of this? So the point of that is that the interior of the greenhouse effect, or the interior of the greenhouse, is hotter than the input coming in, essentially, right?
No, it's that the interior of the greenhouse is hotter than the air around it.
Right. Yeah. Hotter than the air around it. Yeah, which I said is actually due to separation convection, but you want to say it's this radiation effect. So is it hotter than the equivalent temperature of the absorbed input? Like we would just say, here's all the absorbed input energy. Let's use step.
So the only way that you can characterize the temperature of a broadband electromagnetic wave is by doing by looking at the distribution, right? The Planck distribution in this case. And so like the spectrum of the light that we receive from the sun is like 3,000 degrees or 5,000 degrees or something, but that's like not a relevant temperature here.
No, we use the Stefan-Boltzmann law, right? You
can't figure out the temperature of the sunlight from the Stefan-Boltzmann law.
Of course we do. You factor for the inverse square law.
It's not even like a sensible sense of thing. You can figure out like energy flux if you want.
That's what I'm talking about.
Energy flux is not temperature of the. Wait a minute. Hold on. Do you think that?
Can you not hear me? Am I not coming through?
I can hear you. Do you think that you can do you think that you can take the energy flux in the Stefan-Boltzmann law and then just like the energy flux from the sun, for example, in the Stefan-Boltzmann law, and then just substitute and then just solve for the temperature given that energy flux on the left-hand side? Is that what you think is happening here?
Well, that's called effective temperature. So that's what you do. And when you have a Planckian distribution, like if you have an object which is a black body, then it's
the Stefan-Boltzmann law only works for black body radiation, right? We have this. So
that's what we're talking about. We're simplifying to black body systems.
But that's the black body radiation of the sun.
Right? Yeah, so we're simplified to black body systems. Let's say that everything absorbs like a black body. And you can do gray bodies if you want to, but it's still a Planckian spectrum, which is fine, right? So if you have a surface, that's how you compute the thermal equilibrium with a solar input or any input, right? So you use, and with the sun, you obviously have to use the inverse square law. So at the distance of the Earth at the top of the atmosphere, the sun is about 1,370 watts per square meter. Which for a black object in space would be 121 degrees Celsius if it were in thermal equilibrium with that input.
So when you're solving for the thermal equilibrium of a black body, I just want to clarify, you have some input energy source, whatever that input energy source might be, right? You have some input energy source. How do you find the temperature, the equilibrium temperature, given that input energy source?
Well, it depends on the view factor and the shape and everything. So what you do is you simplify to, say, a flat surface, which is perfectly insulated on the backside, so that the only place that it can emit is back towards outer space. Of course, there's some view factor from the sun.
But what's the actual calculation that you do?
Negligible.
What's the actual calculation that you do?
It would be, in this case, because you have a nice simple system.
Just a very, very straightforward system, very abstract. Power input, you know the power input, you know the surface area. Sure.
Flux in equals flux out.
Okay.
Flux in equals flux out.
And then how do you find the temperature from that equation?
Using the Stefan-Boltzmann law.
Okay, so what do you do?
You solve for T.
Okay. Now, the flux in.
And we call that generally effective temperature, but if we're assuming black body systems, then it's just the temperature.
Yeah, okay. I'm glad that we're in agreement. Good that we're on the same page here. So now, the flux in for the glass, right? The flux that enters the glass, power that enters the glass, comes from.
Oh, there it is. Okay, good.
It comes from. Oh, did I close it out? Oh well, it was visible elsewhere.
I got it back. Yeah.
Okay.
I did click on it. You're still just on the diagram, right?
That comes from radiation from the ground, thermal radiation from the ground, and radiation from the sun, right? Now, the actual flux
You're talking about the greenhouse again?
Yeah. Isn't that what we're talking about?
Okay, yeah. Sure, yeah.
So the point is that the flux in is not equal. It's not just equal to the whatever the solar flux is on a given day. Right? Because the point is that some of that light will pass through, so it's not absorbed. So that flux isn't considered. Some of the light will be absorbed by the ground.
This is why you have to do heat. This is why you have to do real thermodynamics. You can't just add up energies all over the place. You especially cannot just add up.
This is literally how you do real thermodynamics.
Because that's like adding temperatures. No, you have to do heat transfer. Heat transfer is a difference of fluxes.
I'm aware.
Heat
Here, let me
transfer
pull
is a
something up
difference
for you.
Right.
One sec.
And heat transfer, difference of fluxes goes to zero in thermal equilibrium.
One sec.
Yeah.
I want to make sure that this is the right thing. No, it's not that one. Is it this one? Just gotta put this over here. I just gotta find it in a. Maybe is it the second half? Is it over here maybe? Okay. Yeah. So here's a. Here you go. Okay. Let me change my screen.
I still just see the diagram.
I know. I'm just changing it. Okay. And just so everybody else can see. So here's what we're looking at. This is some lecture notes that I wrote up for when I was teaching thermodynamics. So this is some fairly straightforward. This is like intro stuff. Here's the Stefan-Boltzmann law that we have. You can talk about all sorts of things. So like, I can assure you, I definitely know what I'm talking about when it comes to thermodynamics. So you don't have to talk down to me. Okay?
I mean, this is just a wall of text. No, I'm not talking down to you. It's fine. I mean, you talk.
These are the lecture notes that I was using when I was teaching at a university level at a large university thermodynamics.
That's fine. I've done that too. Yeah.
You've done that too? No, there's no way you have. No way. Not a chance in hell.
Yes, I have.
I don't believe you. If you don't understand how to compute the equilibrium temperature of the glass, I don't believe you.
I think that you're doing it wrong.
You're missing out half of the emitted radiation.
You're overcomplicating it. Yeah, exactly. Well, anyways, here let's get to the point of your diagram, because I got another nice Easter egg, or not an Easter egg, just another nice thing to present.
Can you see it?
So the point. Yeah, let's go back if you want. Okay, good. Yeah. Yeah, no, I worked for the Canadian Space Agency. I helped launch I actually was a manager for ground calibrations for the Ultraviolet Imaging Space Telescope.
And you taught thermodynamics at a university? That's what you were saying?
Well, I did that just as part of, getting my degree. Everyone, TAs always have to teach, right?
Oh, no, not all TAs have to teach. Do you have a PhD in physics?
This TA did. I have a master's degree in physics, yeah.
Oh, okay. Well, so, I mean, you probably did the discussion sections, right?
The what?
The discussion sections.
Sections?
You weren't like the primary lecturer of a course. Usually master students aren't allowed to do that. Maybe in Canada.
Oh, right. Yeah. I mean, whatever. Yeah, fine. I mean, we do whatever teaching we need to do. Yeah, for sure. I mean, yeah, I've been through the gamut. Yeah.
Okay, so then,
yeah.
look,
I know what it's all about.
What's the confusion? If we're isolating just the glass, then all we have to do is we have to account for all of the energy that's emitted and all the energy that's absorbed. And of course, you can talk about like, we can assume that it's probably going to be, there's some extra energy that's entering the system and leaving the system from convection from the surrounding air. There's going to be extra energy from conduction with the ground and so on. But we can ignore that.
That's why you just simplify it. Yeah.
Yeah. But the point is that like the glass as a system, just on its own, it has and I don't know how many times I can say this. It emits light. It emits light in all directions. It radiates in all directions. You can't just ignore half of it.
Not on its own. But it's not on its own. It's going to
energy conservation applies to it whether it's actually connected to something or not.
I think that's getting really ambiguous. It's going to end up.
It's very not ambiguous.
We have to do
thermodynamics. Energy conservation on Earth is a nearly exact symmetry.
Wow, you love to cut me off. You have to find thermal. We're looking for end states, so we want to go to thermal equilibrium states, right?
Yeah. So this is a coupled system, so you have to solve for that.
System. All right, so a plane parallel system, if you consider, perfect absorptivity, I mean, you can throw in gray body stuff if you want.
Assume perfect emissivity, that's fine.
Yeah, so the glass and the ground have to come to thermal equilibrium. That's the only solution for a plane
they don't have to be the same temperature.
It's a plane parallel system. That's the only solution for a plane parallel system when you have unity, absorptivity, and emissivity and everything.
That's only if all of the radiation's absorbed and all of the radiation, or if all of the radiation's absorbed, right? Like that just
that's
doesn't
why
follow.
You simplify it. That's why you simplify it to do that, so that you can demonstrate the principle, the concept.
But we agree that.
In any case, let's move on. So let's take your diagram. So I'm going to go with your diagram. So let's say it works the way you do, and the result of that is that the ground is hotter, right? Than the
air too.
Than the.
I mean, there's going to be a gradient, obviously, but yeah, the ground will generally be a bit warmer.
Right. So what causes the gradient?
The air. I mean, just the air doesn't conduct thermal energy particularly well.
Right, but what about the greenhouse effect that you're positing here? Doesn't it produce a gradient in temperature?
The radiation is not going to be particularly well absorbed by the air, and so it's not going to cause a gradient in the air temperature.
All right,
at least not a significant one.
Let's talk about the bulk gradient in the just in the different ground glass.
In the air between the ground and the glass. Yeah.
Yeah. So the way that this is extended, right? You extend this and say that instead, let's not think about a greenhouse anymore. Let's just think about the air, and this is happening in the air. So if you extend this to the air, and now we're just talking about layers of air, what's the result of this going to be? The result of this is going to be that the bottom of the air, the air column, the troposphere column, is going to be the warmest part due to this greenhouse radiation mechanism.
Sure.
Right?
At least while you're still in like a reasonably effective equilibrium system. Of course, the thermosphere is extraordinarily hot, and this is for other reasons.
No, let's not do that. No. Let's not switch.
I was just hedging my bets because.
Talk about the troposphere.
Yeah, I was just hedging my bets because a bad faith interlocutor would have been, well, what about the thermosphere? And so, like, I'm just like, obviously, we're talking about the lower layers of the atmosphere here. We're not talking about
the troposphere. The troposphere. Yeah.
Sure.
So this greenhouse mechanism, this radiative balance diagram here, we can generalize that to. I'm just repeating just because I want to confirm that you agree. We generalize this to the air. We talk about layers of air, and then we say that this radiative back and forth mechanism causes a differential in temperature, such that the bottom of the atmosphere becomes the warmest part of the atmosphere. Is that correct?
Yeah, which is true, right?
It's not true, actually.
The bottom
have you forgotten about the adiabatic effect?
It's just true that the atmosphere is cooler as you go higher up, right?
Okay, that's an empirical truth. We're talking about what causes it. So have you heard of the
Wait, so then why did you say, I just said it's true that the bottom of the atmosphere is warmer than the top of the atmosphere. Why did you say that that's not true?
I said it's not true that it's due to the greenhouse effect. So
well,
sorry.
That's the thing in contention.
Right, yeah. So have you heard of the adiabatic effect?
I've heard of adiabatic processes. I've never heard of the adiabatic effect. It's not in any textbook, any thermodynamic textbook I've ever read. But, if you're just referring to like adiabatic expansion or something like this, then yeah, sure.
Right, yeah. So it's actually a fairly simple equation. It's basically like a Hamiltonian, but you just can compute the total energy of a gas particle at any altitude in the atmosphere, right? It's just U equals mCp T, thermal, m mass for the parcel of air, Cp its specific thermal capacity times its temperature, plus mgh, so that's just its gravitational potential energy.
You're just talking about like, what's it called?
Total energy.
I actually made a video on this. You're just talking about like hydrostatic equilibrium with like thermodynamics added in, yeah?
Somewhat, sort of. It's more just talking about energy. And so
well,
you take the difference.
I mean, it is, of course, it's talking about energy, but it's hydrodynamic equilibrium, right?
So you take the differential of that equation, du, the constants drop out, so then you get, and then because we want to talk about thermal equilibrium, du equals 0, so then you just get the equation, you solve it, dt, or t becomes dt, and what is the other one, h becomes dh.
So you here's go, so, okay, yeah, sure. So you're taking the partial derivative with respect to t here, importantly.
So you take, so you just solve dt over dh, and you get minus g over cp. That's called the dry adiabatic lapse rate. It's basically because the
I'm
thermal
familiar with that. Yeah. So I haven't heard it called the adiabatic effect, but yeah, there's actually like a nice, it's actually a nice Wikipedia article on this that gives a good overview if I can find it.
Yeah, so it's called the dry adiabatic lapse rate, and that is, it's
it's the lapse rate. That was the thing.
As that value when the air is dry. The air is generally wet, so if you add in the latent heat release from water vapor, given the empirical measurements of how much water vapor there is, then you get, and you can compute it directly, the minus 6.5 Kelvin per kilometer drop in temperature with altitude.
Yeah, sure. This is all fine. In order to solve the relevant differential
it's
equation, though, you need to know
because there's mutual.
It actually is
there's
fine.
actually mutual exclusivity. Do you understand the concept of mutual exclusivity? So you had said that it's the greenhouse effect which causes the gradient in temperature in the atmosphere. I just proved to you with mathematics.
To be clear, you didn't, and I'll explain why it's not fine.
The adiabatic physics is what causes the gradient in temperature in the atmosphere. So which is it? They both can't be true.
I didn't say that it's only. To be clear, so okay, again, you're confused, and I can clarify.
Well, I'm going to make it mutually exclusive here, and not that you say it's only a little bit, because with the adiabatic calculations, you perfectly nail the lapse rate. You perfectly nail it. So there's no room left for the greenhouse.
JP, I don't know if you know this, but the gradient that is established in a greenhouse is the adiabatic effect. It absolutely is.
We're talking about the whole atmosphere.
It's the same thing. The reason why there's a gradient is because the ground is hotter than the glass, right? That's why there's a gradient, and it's the same reason why why there's a gradient in the air. It's the reason why there's any there's also gravitational effects that take place over a much larger
distance. The gradient in the air is caused by the adiabatic effect.
So in a physical greenhouse, the relevant pressure differences are pretty small because there's not a lot of gravitational potential energy between the bottom and the top.
But let's talk about the whole atmosphere.
The point is that when you're solving the differential equation, and I did this like 3 weeks ago for Venus because it was an interesting question. When you're solving the differential equation, you have to input the temperature of the base layer. And the temperature of the base layer, of the very bottom layer, or I guess you could also specify the temperature of the top layer if you wanted to, but the thing that we measure is the base layer. So the temperature of the very bottom layer of the air that's going to be at the same temperature as the ground. It's at least going to be the same temperature as the surface of the ground. If you dig deeper, of course, it'll be lower. Yeah. And so that's a piece of input data that's controlled by the greenhouse effect, right? The whole claim.
You're switching reference frames here. Actually, you're changing the entire structure of this argument.
And you're confused. And if you let me explain.
Your explanation is sophistry, though. The gradient of.
So the whole point is that the ground becomes a higher temperature than it would be if the glass wasn't there. And if the ground is a higher temperature as a result of the greenhouse effect, because more energy is being absorbed by the ground than is being emitted off into space, that will induce a gradient from this will induce a lapse rate from adiabatic expansion in the atmosphere. That's exactly what's causing the gradient. And it's a similar thing that happens in a greenhouse, in like a physical, literal greenhouse. It's just the gravitational effect is very small because the height is very small. So you essentially are just going to you could treat the air as just like a conductive medium. There's not a whole lot of flow. There's not a whole lot of other stuff. So you're going to get a different physical mechanism that causes the gradient between the hot ground and the cooler glass, but you're still going to get a gradient as a result of the ground being hot and the glass being cool. or in the case of the greenhouse effect on the Earth, the ground being hot and the upper atmosphere being cool. Do you have any objections to what I just said?
Yeah, and I would
Okay, which
say
part?
that.
Go ahead.
Yeah. So the gradient in the atmosphere is caused by this adiabatic physics. That's what causes it. The calculations match perfectly with empirical measurement. Now, we know for a fact that due to the adiabatic physics, there has to be a gradient of a temperature in equilibrium, in an atmosphere in equilibrium. There has to exist this gradient of temperature. It exists by itself due to adiabatic physics. Now, given the definition of an average, right? That means that the bottom of the atmosphere has to be the hottest part of the atmosphere. You cannot find the average at the extremity of a distribution, correct? So given that the gradient must exist due to fundamental thermodynamics, right? That means that the average, if you expect the atmosphere to have an average temperature, and we do, you cannot find that average at the bottom of the atmosphere. It's going to be found somewhere in the middle, probably, of the atmosphere, right? Given that we're talking about averages. So you simply look, okay, what's the mass average location of the atmosphere then? You know, you can integrate that. It's roughly around 5 kilometers. Great. So what do you do with that? What's the temperature there? The temperature there is actually roughly around minus 18 degrees Celsius, which just happens to coincide with the effective temperature of the Earth. So you use that as your reference point, and then you get the surface temperature directly, average surface temperature of plus 15 degrees Celsius. So just from the adiabatic effect and the definition of averages, you calculate perfectly, saw any greenhouse effect, what the average surface temperature is.
Did you listen to what I said? Because it doesn't sound like that addressed what I said
Well,
at
I
all.
did. Did you listen to what I just said? You seem to be ignoring that.
Yeah,
the
you're making the claim
on
that
its own.
you're making the claim that the effective temperature is exactly what we would expect if there were no greenhouse effect. But that's not even the point that I.
No, that's
I wasn't even talking about that.
Those words make no sense at all. You just said something that makes no sense at all. We can't move past that. What? If the effective temperature is set by the absorbed input from the sun. So the effective temperature of the Earth is given by the absorbed total solar energy, and what's the effective temperature of the whole Earth going to be then? That
And the emissivity, right? Of course, it also depends on the emissivity.
Yeah, so we just say that the emissivity, we usually just say that the emissivity is 1. If the emissivity is less than 1, then it means that, you know, that's going to by itself explain why the surface might be higher than the effective temperature.
So how do you think what you said addressed what I said? Can you summarize what I said?
Well, I can, but it was all just so wrong. It's difficult for me to think in those sort of wrong physics terms.
That's how I feel too about what you said. So,
right.
So can you summarize what I said?
No, not really. I mean, yeah, I can. So what did you say? You were equivocating between a real greenhouse, saying that the gradient is really tiny there. I don't know why you'd bring that up, because we're talking about the whole atmosphere, where the adiabatic effect is real, and where, you know, there's a pressure gradient, and the adiabatic effect has many kilometers to have its effect. So I mean, like, no, I don't want to repeat what you said, because it's wrong. It's just
okay. So it wasn't even a correct understanding. My point is that the relevant factor here in determining the gradient is that the ground is hotter than the, you know, higher up. That's what that's. Can we agree that fundamentally that's what causes a gradient?
Yeah, and I love that you said that, because you're claiming that the greenhouse effect then sets that gradient, but that's wrong.
No, the greenhouse effect sets the temperature of the ground, which then induces a gradient. That's what I've been saying this whole time.
Man, you love to cut people off.
Well, you strawman me, so I'm going to cut you off.
It's mutually exclusive logic. It's one or the other.
You're confused.
Right?
You're confused. That's not even my claim. My claim is that the greenhouse gas. My claim is that the greenhouse effect is what causes the ground to be hot, or hotter anyway.
No. Given the adiabatic gradient exists, then the average cannot be found at the extremity.
Do you think that the ground is hot because of the adiabatic? Oh, this is so confused. Do you think that the ground is hot because of the adiabatic effect?
There's two things. There's two reasons why the ground is hot. One, sunlight is really hot and warms it, so that's where you'd expect the hottest part of the whole ensemble to be, because that's where the heating occurs, is mostly at the ground.
Okay, so it's not the adiabatic effect that's causing that gradient. Then it's the temperature of the sun in your view.
No. The adiabatic effect is its own gradient.
It's not called the adiabatic effect.
That's what it is. Well, that's what I'm calling it, because that's what it is. The effect is to create a gradient of temperature in the atmosphere. That's what its effect is. It's a very simple calculation.
If the ground
and it leads
were the
to
same temperature,
values.
So let's scale down for just a second, then we can talk about the whole atmosphere. If the ground were the same temperature as the glass in a greenhouse, would there be a gradient?
Of temperature?
Yeah, any significant gradient.
By definition, no, because you just said that they're the same temperature.
Right, okay. So the only way to get a gradient is if the ground is hotter, right?
Right, but in a plane parallel system with unit emissivities and absorptivities and everything, to make it simple, the only solution in plane parallel system is that they're going to be in thermal equilibrium and therefore the same temperature. You can just get rid
Thermal
of that
equilibrium
gap.
doesn't mean the
Just
same
make
temperature.
those two and just make those two surfaces touch. Like that's what's the beautiful thing about a plane parallel system, right? So just make those two surfaces touch. What's going to happen? They're going to be in thermal equilibrium, reach the same temperature. You put a vacuum gap between them. What's going to change? Nothing. They're just exchanging energy.
No, the point is that some of
they're still going to be
some of the energy won't. Not all the energy will be absorbed by the glass, for example. So they don't have to be at the same temperature.
We're saying unit. We're simplifying things to unit emissivity and absorptivity.
Yeah, if glass doesn't have unit emissivity and absorptivity, that's just not.
That's
just not
what
the
we're
case.
doing. I mean, you're equivocating. We're making it simple. We're making it simple so that we can look at the basic problem and what happens in a perfect scenario.
Well, you're simplifying in such a way that you're losing the relevant physics.
No, it's not losing the relevant physics because less will happen, right? The only thing can happen is if you have lower. Well, if you have the same absorptivity but lower emissivity, then you can have higher temperature.
If you put them next to each other, they'll reach the same temperature because of conduction, right?
Right.
If you separate them by a vacuum, they no longer conduct.
No, they exchange heat by radiation.
Heat coming to thermal equilibrium via blackbody radiation does not necessarily imply the same temperature.
It depends on your view factors. In a plane parallel system with unit emissivity and absorptivity, the view, work it out. It works out to equal temperatures.
So if the plane is entirely covered, like the entire Earth is covered, and you have no other sources of input or output energy, then that might be the case. But that's not what a greenhouse is, and that's not what the Earth is.
Well, there is no other input energy, right? The only input is solar, right? There's no more additional input inside the thing. Everything is downstream.
So there is energy input. That's the point.
From the sun, yeah. The sun is the solar input. That's the only input.
Yeah,
right?
And that's relevant.
What's happening inside the greenhouse effect? There's no further inputs inside. There's just whatever's totally absorbed.
So we agree, and we kind of got off topic, but we agree that if the ground were the same temperature as the glass, then there'd be no gradient. If the ground is hotter than the glass, then there is a gradient. Now, that gradient can be caused by in some cases if the greenhouse, the physical greenhouse had like windows in it, it could be caused by convection. If the air is particularly still, it can be caused by very, very slow conduction. In a greenhouse, it'll generally be very, very slow conduction. That's going to induce a gradient, right? Because you have thermal energy flow across a gas. Now, in the case of the atmosphere, you have a lot more complicated dynamics that are happening, and in this case, you do have like adiabatically induced lapse rates because you have significant gravitational potential differences, significant pressure differences, and so on. But the point still stands that you need to have a hotter ground. Like if you fix the temperatures of the ground and the top of the atmosphere, then you will have no gradient between them, right? It's actually an interesting question. I'd love to do the calculation there. But like the point is why would you do that?
Because we're talking about
my point is that
actually
in order for the adiabatic lapse rate to exist at all, you have to have the ground as hot.
No, that's not what the equation shows at all. It's a simple equation. I can say it to you again. U equals mCPT plus mgh. Du.
I'm looking at it right now.
Cross out the m's. Du equals 0. You have what is it? Cp dt plus gdh. Solve for dt/dh, you get minus g over Cp. That's called the dry adiabatic lapse rate. If you redo that, factoring in water vapor latent heat release, then you get the wet lapse rate, and both of those values perfectly match the empirically measured
and how do you determine the temperature profile? How do you determine the temperature profile once you have the lapse rate?
Right, absolutely. The absolute profile? Yeah. So first of all, now we have the lapse rate, and no, I'm going right to the answer. I'm going straight to it. So the lapse rate exists on its own always, right? So it means that if there's going to be an average state of this system, the average state of the system cannot be found at the bottom or the top. It's going to be found around the middle. So now you need an anchor point. Where's the anchor going to be? Let's use an average, right? So let's use the mass average. right? You integrate that, it's around 5 kilometers, right? What's the temperature there? Temperature there is about minus 18 degrees Celsius, which just so happens to be the effective temperature of the Earth. You know, balanced with the input. You know what effective temperature is.
Okay, so what?
Right. So use that as the anchor point, and now you have an absolute profile, and you can calculate the absolute temperature of the bottom of the atmosphere, which is plus 15 degrees Celsius. You nail it, and we've done all that without any greenhouse effect at all.
So do you think that the let's say that there's no water in the atmosphere, right? Just for the sake of argument, simplifies things. Do you think that this will capture all of the energy input and energy output from the system? You know, it's essentially accounting for just the work produced by expanding gas and the gravitational potential changing as a result of raising and lowering. Do you think that that accurately accounts for all of the energy that's floating around and being exchanged in the system vertically?
That's called the dry adiabatic lapse rate. Yeah, you remove
right. Do you think that accounts for all of the energy, all of the relevant energy?
In this system, yeah, generally it does. That's how you calculate the lapse rate.
If you have a given parcel of air, right? Because this is what we're talking about. We're talking about a parcel of air when we're doing this derivation. If you have a given parcel of air, yeah, it's a small parcel. What are the sources of energy for that small parcel? Can you just list them for me?
Assume thermally. Yeah, so you assume thermal equilibrium, and you say there's some source of energy. I'm just asking,
what are the sources of energy? What are they?
Well, for the Earth, the only real source of energy is the sun. I mean, you could say
if that's how we did these calculations, then you wouldn't have a term that involved work.
You could say that the Coriolis effect is another source of energy if you want.
So there's the work done by it's hard to call it a source. Perhaps you should just call it a work. There's the work done by the gas in expanding, right? There's gravitational potential energy. Is that everything?
Well, generally, yeah.
Except no, it's not, because obviously there's thermal energy all over the place that you have to account for.
Well, we're assuming thermal equilibrium, right? To simplify things so that we can get basic characteristics. And so we calculate
so you can't just assume that the thermal energy in is equal to the thermal energy out, when the whole point is that you're doing an energy balance equation. That would be true. Thermal equals, sorry, I mean radiative energy, not thermal energy. The whole point is that radiative energy in only equals radiative energy out if there's no other sources of energy. But here we have work that's being done by the gas. We have gravitational potential energy. So the radiative energy in and the radiative energy out don't have to be the same.
For conservation of energy long term, we generally consider the Earth to be in radiative energy equilibrium with the sun.
We're talking about a given parcel of air, not the entire Earth. It seems like you're doing the same thing that you were doing for the greenhouse diagram. You wanted to keep talking about the whole system rather than talking about the isolated thermodynamic system under consideration here.
We're talking about thermal equilibrium. We're talking about the system has come to thermal equilibrium.
Well, we're not talking about thermal equilibrium, by the way. We're talking about energy conservation of a small parcel of air. That's the relevant fact here.
That's what thermal equilibrium also means. Energy equilibrium.
Thermal equilibrium and energy conservation are not the same thing.
Also means there's no more heat transfer, right? Yeah, there can be still energy flow, but just because energy is flowing doesn't mean that there's heat transfer. So you can have energy flowing.
Thermal equilibrium is not the same thing as energy conservation. Like, that's obviously not true. You have a master's in physics?
Thermal equilibrium means the temperature isn't changing anymore.
Yeah,
right. That means
thermal equilibrium in general means that the macroscopic variables are constant in time.
Right.
But you said that thermal equilibrium is the same thing as energy conservation. Energy in equals energy out. That's energy conservation. But it's not like the only energy in is radiative energy and the only energy out is radiative energy. There's work done by the gas, which is energy out. There's the gravitational potential energy, which is changing with altitude. Then there's the radiative energy that's coming in, and then there's the radiative energy that's leaving.
Right, yeah, and so that's all factors.
And so you can't just say that the input radiative energy is equal to the output radiative energy. That's false. It's strictly false.
That's called conservation of energy, because
you're neglecting the other energy sources. It's not called conservation of energy when you ignore two of the energy sources.
I'm not ignoring them. I actually factored them all in. I discussed the gravitational potential and the other
gas does work.
And then I also discussed
the gas. Okay, we can even just ignore gravity actually for the sake of argument. We can just ignore gravity.
Reflective of the.
If you have a gas that's expanding.
We can't ignore. What are you doing?
I'm making this easier for you because you clearly don't understand what we're talking about here.
Let's not ignore gravity.
Okay, we can make it more complicated, but then I promise you won't understand it. I promise.
running now.
We can include gravity.
let's
That's no
not get rid
problem.
of
So okay, so we agree that there are 4 terms that we have to include in our energy conservation equation for a parcel of air, right? There is the work done by the gas to figure out, just to do an energy balance equation. This is very straightforward. This is engineering 102 stuff, right? You have a parcel of air. You have the work done by the gas that contributes negatively to the total internal energy of the gas. You have the gravitational potential energy that we have to account for because we're including gravity, and so that will depending on its altitude, that will change the energy of the gas. Then we have the radiative energy that's coming in from the surroundings. Most of that energy will just pass right through because air is transparent, but not all of it will. And then you have the radiation of the gas itself. The gas has a temperature, so that parcel of gas will indeed radiate. Now, those are 4 terms. Why aren't all 4 of those terms included in the dry adiabatic lapse rate?
They are.
Oh, no, they're not. There's no radiation accounted for in the lapse rate at all.
That's a claim. That's a baseless claim. I said they are because...
Okay, let me share my screen with you. Let me share my screen with you.
Equilibrium.
Here.
We're assuming thermal equilibrium so that we can solve this system.
Thermal equilibrium doesn't mean that the radiation in equals radiation out for a parcel of air.
It means that the temperature isn't changing anymore, so it means it's all balanced. You can
for
discard
a given parcel of air, it doesn't mean
absorbing. The parcel of air we're looking at is not absorbing more energy than it's emitting. With its surroundings.
Nobody said that. That's energy conservation.
Well, that's where you're trying to go. That's where you're trying to go. That's what you're trying to do.
That's not where I'm trying to go at all.
Yeah, you are. Yeah.
Why, instead of telling me what I'm trying to do, why don't you just listen to what I'm trying to tell you?
Well, because what you're saying is you're equivocating, you're running away from the facts.
Okay, so
you're all over the place.
So you can see the screen that I'm showing you, right?
I think I got to click it. Okay, there we go. Yeah.
Okay, so this is the energy conservation equation that's relevant here for producing the dry adiabatic lapse rate, right?
That's one way. That's one way to formulate it. Yeah.
Yeah, and then you can do some rewriting and you end up with this thing. And then you can do the normal business. You can relate temperature to pressure and all these lovely things using these kinds of equations. Anyway, the point is this the relevant first law of thermodynamics, the energy conservation equation. Now this term here, that is the change in internal energy as a result of changes in temperature, and this term here is the work done, right, for an adiabatic process. Can we agree on that?
Yeah.
Okay, so now where in this equation is the radiated energy absorbed or the radiated energy emitted?
So are you contradicting this Wikipedia derivation of the dry
yes, because this doesn't.
You're saying that this is wrong? Oh, so you should write the
Wikipedia
model. People, you should rewrite this page then. You better rewrite this page and tell them that this is not the correct way to derive the adiabatic gradient. You better let them know. Right?
So the dry adiabatic lapse rate the dry adiabatic lapse rate is defined to be this approximation, but this approximation isn't perfect.
It actually is perfect because it works out empirically perfectly. If you factor in latent heat release with water vapor, you perfectly nail.
Oh, okay, so wait a minute, hold on. Are you telling me that this doesn't work? Are you telling me that this doesn't work perfectly?
It does work perfectly. It works perfectly.
Okay, so hold on. I just want to double check. So here's the moist adiabatic lapse rate. Where is the radiation in this formula here for the moist adiabatic lapse rate?
You better let them know that they don't. You better let them know that they did it wrong, because guess what? You compute that and you perfectly get the empirical measurement. Because why? Because we're assuming a thermal equilibrium system, and because this system has been empirically measured over time. See what the thermal equilibrium condition is.
Let's go do some digging.
Yes, it perfectly matches.
Let's go do some digging.
Measure. So what is the average adiabatic or wet adiabatic lapse rate? What is the wet lapse rate?
It says typically around 5 degrees Celsius per kilometer, is what it says typically.
It usually is minus 6.5. Well, whatever. It comes usually to minus 6.5. I mean.
Okay, so are you telling me that Wikipedia is wrong?
No, it's about minus 6.5 Kelvin.
Wait, are you? It's minus 6.5 Kelvin per kilometer? Are you telling me that Wikipedia is wrong? That it says it's typically 5 degrees Celsius per kilometer?
Oh, I see.
You better write to them. You better write to them and let them know that they're wrong. You see how stupid that is?
So you're really not capable of doing science. All you do is spout what you've learned. You can't actually think like an intellectual. You're not an actual scientific philosopher. You just spout what you learn. You're not actually an intellectual. You just have a good eidetic memory or something, and you like to just bash people with facts. So let's go over something. So you said that the greenhouse effect. You said that the greenhouse effect causes the gradient of temperature in the atmosphere. I pointed out to you that the
It causes,
adiabatic lapse
the
rate.
greenhouse
Now you are
effect is the
flying all
thing
over the
that
place.
produces the thermal
Now
gradient.
you're flopping all over the place.
The thing that
No,
produces the
adiabatic effect. You're looking straight
temperature of
at
the
it.
ground.
You're looking straight at the equation, which
Yep.
computes and creates and causes the physics
So
which
this
causes
is the mechanism
gradient of
that
temperature in the atmosphere.
given a
That's the
difference in
mechanism,
temperature,
that's
this
right.
is a mechanism that produces a gradient.
Not
But you still
given a
need to have the temperature at the bottom.
not given a difference in temperature. This is what creates the
If
gradient.
you
This is what
fixed,
creates
if you
the
fixed
gradient.
the temperature at the top and the bottom of the atmosphere to be
You
the
can't
same,
do that. You can't do that. Why would you do something insane? You can't do that. What are you talking
you
about?
have
Why
no
would you even
ability
do
to
that?
consider a hypothetical, do you?
Yeah, it's a baseless hypothetical. That's not what exists, and it's not
This
possible
is such
to do
a
that
MAGA
because of
take.
the
You can't even
adiabatic
consider a
effect.
hypothetical.
Well, I can, but it's stupid because that's
Okay,
not
then
what
consider it.
exists. What
Consider it,
exists
JP.
is the adiabatic effect.
Obviously, it doesn't
is this
exist. It's a
adiabatic
hypothetical,
physics.
dipshit.
Yeah, so what do you want to? Oh, so, you're calling names. I've just beat you, man. You're starting to call me names. I just fucking trumped you.
Are you sure? Because you were the one who. I just want to replay something for you.
I just fucking destroyed you. I just destroyed you.
I'm going to replay something really quick.
So are you contradicting
you are
this
looking
Wikipedia
straight
derivation
at-
of the dry
Yes,
adiabatic
because this
lapse rate?
doesn't-
You're saying that this is wrong? Oh, so
I'm
you
saying
should
that
write
it's a
the
simplified
Wikipedia.
model. Hold on, and he
Perfectly
can't
nailed.
okay,
Okay,
so wait a minute, hold on. Are you telling me that this hold on,
Better let them, because of
this formula here for the moist adiabatic lapse
well, you
rate?
better let them know that they don't. You better let them know that they did it wrong, because guess what? You compute that, and you perfectly get the
It's a
empirical.
little bit further.
Has been empirically measured
you?
over. It's perfectly measured. It's adiabatic or
3 Celsius.
well, whatever.
Kelvin.
You just do is about what you learn.
See how stupid that is?
So you're really not capable of doing science. All you do is spout what you've learned. You can't actually think like an intellectual. You're not an actual scientific philosopher. You just spout what you learn. You're not actually an intellectual. You just have a good eidetic memory or something, and you like to just bash people with facts. So let's go over something.
So I know
What was
you
the
couldn't
point
hear
of
me, but that
replaying
was me replaying you, just repeatedly calling
heard
me a
it.
non-intellectual and non-scientist. So like, who wants to? Do you want to start with doing the insulting stuff, or?
Well, that was an intellectual challenge. I didn't debase myself to use actual bad language.
Oh,
which is
you're just
like
mad because I
childish,
used
right?
a mean word. I see.
Yeah, it reflects on your quality of a debater, of a person who can actually hold a scientific debate. You have to revert to childish language instead of using.
Okay, so
more
you know that scientific
sophisticated,
debates aren't held on
challenges.
the internet, right? They're held in peer-reviewed papers. So
Well,
why don't you go
you are
point to me a peer-reviewed
No,
paper
they're
that's
not.
making the argument that
No,
you're
they're
making?
not.
Sure,
They're not
that's
held
where the
in
actual
peer-reviewed
science happens.
But, yeah. Oh, so now you're reverting to peer pressure, right? Peer pressure.
No,
You know
that's just
a
where the
debate
science
fallacy,
happens.
right?
Like historically,
that's a
that's
debate
where the science happens. You think that the science happens
Yeah,
in like
because
live stream
because
debates?
you can't do it, right? Yeah, because you can't do it. You're staring right at the adiabatic effect and the mechanism that causes it, and denying that it's real. And now you're saying, "Go."
I think that you're
Go
a
to
little bit
peer
confused as to what I'm saying. I agree that the
No, I
adiabatic
think you're
that the adiabatic that adiabatic processes produce lapse rates. I agree that is a mechanism by which a lapse rate is produced. The question is what is the origination of the gradient, right? Why is it that there's a gradient at all? Why is it that it's not just all at the same temperature?
It's
Sophistry?
because of this physics. It's because
Okay,
of
so
the
then- so
equation
then
you
tell
were just
me,
looking at.
if it
It
were the
creates,
case-
it causes the lapse rate.
So I'm glad that
it.
we agree. I'm glad that we agree. So if it were the case that this will produce a lapse rate regardless because of this magic adiabatic effect that you keep calling it,
Oh,
then
you're
tell
calling
me
it magic.
if you
are such a
because
joke.
it's not called
You're
the
a
adiabatic
joke.
effect.
It's
That's
magic.
why.
It's magic.
So,
Is this recorded?
Here's the question.
Is this
Yeah,
I
it's
wanna
going.
fucking
It's
copy
definitely
it.
going
I
up on
wanna
YouTube,
copy
by
it.
the way, because your crash
Oh
out is
man, I
hilarious.
want to copy
So
it.
JP.
Yeah,
so
it's,
JP.
it's magic.
Here's a
No,
hypothetical.
you just said
JP.
that the adiabatic effect is magic.
Here's a hypothetical. Okay,
no,
I gotta
no,
mute you
no.
again,
We're
'cause-
gonna.
So JP, here's a hypothetical. If you fix the temperature of the bottom layer of the air, you fix the temperature of the top layer of the air, will there be a constant non-zero lapse rate between them? Go ahead.
That's a dumb question. We're going to go back.
Oh, you can't even engage with it.
you
Oh, you're so
calling-
anti-intellectual.
you
You're not
calling
even a
the adiabatic
scientific
effect.
philosopher. You can't
You
engage
called the
intellectually with the
adiabatic
evidence.
physics
You're not even
magic.
capable of doing science. You just have an eidetic memory. See how
Equations that
stupid
you
that
were
is?
staring straight at to be magic. You're a joke.
Well,
You
it doesn't
called
say
them magic.
adiabatic effect anywhere, by the way.
You are a joke. You're a joke. You're a joke. You called equations
Hold
that you
on,
were
hold
looking
on.
straight at to be magic.
I gotta do a thing. Please be patient.
You said magical adiabatic effect or whatever you called it. Magic. Yeah, I like to call it an effect because the effect is to create the gradient. I mean, it's simple. It's just words.
1 sec. Give me just 1 sec, okay? I'm
What,
powering up.
you got to back
I'm
up
powering
again?
up. No, there's about to be something that's super good. You don't understand the adiabatic effect because your cognition is conducting heat into the environment faster than the proposition can stabilize inside your skull. That's what happened. The argument entered you as a compressed state variable and it immediately expanded into stupidity without performing useful work. You said the gas gets hot because pressure is hot. Pressure's not hot. You thermodynamic farm animal. Pressure is a mechanical state relation. Temperature is a statistical characterization of microscopic energy distribution. Compression performs work on the gas. Molecular velocity distribution shifts upward, and because the process is approximately adiabatic, the energy cannot escape as heat. That's why the temperature rises. How does it feel to lose?
So you think that impresses your followers when you do stuff?
No, it's a bit. It's a bit. He's gone, by the way. It's so funny. Every single time, it's so funny. So good. I love that. All right, we have a bunch of super chats to read, but we'll read them really quick, and then we'll bring up our next guest. Yeah, I need to start saying, you fucking lost. It's so funny. Deathless Light is such it's so funny. Also, his inability to, like, handle a hypothetical was crazy, and it's so typical of, like, brain-dead maggots. From Matt Lloyd with the £5, JP, to a man who has probably spent 2/3 of his life doing very advanced math, I think you're confused about the math. Yeah, I think he was. Actually, he wasn't even... Okay, we lost it for a second. He was just struggling with the energy balance equation. Yeah, he was Canadian, yeah. From A Matter of Thoughts with the $5, hey Dr. Blitz, having issues. Had a guest say electricity is visible because lightning. I argued it's not because atmosphere. Was I wrong? So electricity, the only time you can see electricity is when you're seeing, like, a spark. And that basically is lightning, or at least it's closely related to lightning. Lightning is a kind of spark. And the reason why it produces sparks is there's two reasons. One, they're hot, so they glow. The second reason is because they're basically knocking the flow of electrons through air is knocking electrons out, and you end up with ionized gas or plasmas, and then upon recombination, it'll produce more light. When the electrons recombine with other atoms, they'll produce more light. From Tim Davidson with the $2, Metal Gear Defense, my source, I made it the F up. Oh, there you go. From Robert Roseberger with the $10, talking to willfully ignorant people and trying to get through to them is much more difficult than doing quantum mechanics. I agree. I absolutely agree. From Joe White with the $10, the only math the caller has done is the political math. Yeah, it is kind of weird. Like, he knew enough that I could believe that he has a physics background, or at least like an engineering background, but it's very, very strange that he didn't understand the thermodynamic or the energy equilibrium of the glass. It was just, I didn't understand that at all. Connor Hendrickson said 440 joules for Unc Alert, which I don't appreciate, but I appreciate regardless. From Grimmy with the $5, curious what your opinion on desalination plants and their effects on the environment due to their dumping of waste. Brian, I don't really have any opinions on them. I don't know them. From Mr. Kiki with the $5, this guy is the epitome of what's holding us back as a species. Moderate intelligence clearly being hijacked and compromised by ego and dogma. Yeah, that was rough. From Sustaining Nimbus with the $2, you just bash people with the truth. How dishonest. You're right. You're right, I do. That is what I do. And from Jack Fetter with the $10, I don't know who is right here. I stopped caring after the first hour. What I'm fairly sure of is this guy never taught a thing to anyone. Want to know how I know this? Because he never shuts up. That's true. I had to mute him in order to get him to let me speak. From Wattcast with the $2, it's a sign of low intellect to resist hypotheticals. Yeah, it is. I kind of expected that we would just have a conversation, because in fact what would happen, by the way, if you held the temperature of the ground at a certain temperature and the temperature of the air at a certain temperature, what you would find is that there is a gradient, but it's not constant. Because if the top point of the air, the top layer of the atmosphere, is held at a fixed temperature, then there'd still be enough room in between to have a sort of swing, but you would end up with kind of it goes down and then it goes back up. And the shape of that function would just depend on things like various emissivities, various convection processes, and so on. It'd be a little bit complicated, but it'd be interesting. But it certainly wouldn't be a constant gradient like in the adiabatic lapse rate, which proves his point false, that it does depend on the boundary conditions. Because of course it does. Of course it depends on the boundary conditions. Um, and of course, it would be a second-order differential equation as well. Okay, so we have a poll. Haley, thank you for starting a poll. Oh, it already ended. Okay. And from Matt Lloyd with the £10. To clarify my last chat, because it wasn't very clear, I was pointing out how ironic him saying you don't understand the math to someone who has done math for most of your time on Earth. Yeah. I mean, like, it was also like I didn't want to qualification flex, but to be clear, I do have a PhD, and like, he's not a scientist. He doesn't do science, but like I am published like more than a dozen times in the last 5 years, so. Like it might that is like my job. All right, let's bring up Trump is awesome. What a name. Oh, where'd they go? Where'd they go? Okay, well, guest box is currently empty. Okay, let's bring up Black Sun Crusader. Black Sun Crusader, how's it going?
Hey, how's it going?
Doing all
so
right.
I was wondering, do you believe life begins at conception?
Biological life, sure. Now, but we can get into that in a sec. I just want to ask a few questions just to make sure that we're not wasting time here. Is that okay?
Go for it.
So are you MAGA?
No, I'm not specifically, no.
Are you conservative?
Yes.
Okay. And just so then I, you know, do you like some of what Trump's doing? Do you support Trump, even if you're not MAGA?
There's things I like and there's things I don't like.
Okay, that's fine. Just a few basic questions, then we can get onto the topic. So first, do you think that humans are the main cause of climate change? If you think climate change is real, of course. If you don't think it's real, then the answer is no.
Well, I think it's real, but not on the span that they're saying, because the world constantly changes every single day. No day is going to be the same. It never has been throughout all of history.
So do you think that
been changing for millions of years?
I just need a yes or no, and then we can talk about them later if you want. But I just need a yes or no.
I guess no.
Okay. Do you think that the vaccines that we typically administer to children are generally safe and effective?
I'm not too sure. I don't have enough knowledge in that.
That's fine. And do you think that humans evolved from non-human ancestors?
No.
Okay, cool. And I'm like, these aren't going to be used against you. It's just I just ask those questions to everybody because I'm curious. Okay, so you wanted to ask. So I could just explain what I'm saying, and then we can talk about what you were saying. So when I say that MAGA is anti-science, what I mean is, like, obviously it's a political movement, and like political movements don't have like ideas, right? But there are like ways that you can associate certain sentiments or certain philosophies with political movements. And so what I'm saying is that if you look at the people who generally self-identify as MAGA or right-wing or something like this, you generally find that they are less likely to accept inconvenient political or inconvenient scientific consensus. So like, they'll accept like basic scientific things that aren't politically inconvenient, but if something goes against their politics, they're less likely to accept it. And then the second thing is that you can look at the Trump administration or, you know, conservative policies in general, and what you'll find is that those policies have a tendency to weaken or undermine the institutions that produce the or the politically inconvenient scientific facts. So that's what I mean when I say MAGA's anti-science. And, you know, maybe we can talk about that, but it sounded like you wanted to talk about something else as well.
Can you give me an example, though, of the first part that you made?
Yeah, the one about how, like, generally as a group, conservatives or MAGA types are less likely to accept scientific consensus?
Yes.
Yeah, so, like, I can just go point at the... So do we agree that the scientific consensus, as in what the vast majority of relevant scientists believe, is that climate change is real and is caused by humans?
I could say so, yeah.
Okay.
I'm pretty sure that is what they're saying.
Because,
so,
I mean,
yes.
Yeah, so what is the case is that liberals tend to be more likely to believe in climate change than conservatives do. I can show you data on that. And that's like worldwide, by the way. It's not restricted to just the US. I have a poll here.
I believe that, yeah.
Okay, so that would be an example. Climate change is politically inconvenient for the political right, because it indicates that we can't just do whatever we want with the way that we do electricity. Basically, it's in some sense against a direct free market, and so it's politically inconvenient if climate change were real and if we were causing it. And so the people who are conservative, who are right wing, are less likely to accept it as being real because it's because it's politically inconvenient. So that's an example. I have more, but it's the kind of example I'm talking about.
Great, thank you.
But yeah, so that's the claim, and we could talk about climate change, we can talk about climates, we can talk about various other medical things, we can talk about evolution, we can talk about the age of the Earth. All of these things. I mean, some of them are religiously tied, not all of them are, but these tend to be aspects of scientific consensus that are unaligned or non-aligned with the politics of the right wing, and so they are more likely to be rejected. And then we can just go look at the second criteria, which is just that the Trump administration in particular, which is, how I'm talking about MAGA, the Trump administration is particularly egregious with regards to the amount of damage it's doing to the scientific institutions in the United States. It's seeking to defund our scientific research to the tune of billions of dollars. It has cut scientific grants for explicitly political reasons. This has now been proven in court. It has shut down scientific labs because they produce politically inconvenient science. It has shut down space observatories like space telescopes because, again, they produce politically inconvenient data. So this is kind of across the board a characteristic feature of the Trump administration. So that's why I make the claim that MAGA is anti-science.
Okay, I can agree with that.
Okay. So what did you want to talk about? Because if we're in agreement on that, then I don't know how much else there is to talk about.
Yeah, I guess there's not really too much. We do have a lot in common in that regard, but I guess there is a couple questions I would like to ask you. Yes, one is
Sure.
About life beginning at conception, what you take on that.
I
And
agree.
I have a different question following up.
I agree. Life, like biological life, is you have a new organism at conception. Absolutely agree.
Okay. And my final question is, do you believe in the Big Bang?
Probably not in the way that you understand it, but yes, I think that the universe expanded from a hot, dense state about 13.8 billion years ago.
Can you elaborate on why you believe that specifically?
That's where the data leads.
But also at the same time, science has also said that nothing or something can't be created from nothing. So
I'm not
how
making
is
the
the
claim
Big
that
Bang
something was
going?
created. I'm not making the claim that something is created from nothing. I'm just saying that the universe was very, very small and very, very hot 13.8 billion years ago.
Gotcha. Okay. Well, I guess that was all. So thank you for your time.
Okay. Quick question. How do you feel about the Wehrmacht?
The Wehrmacht?
Yeah.
Oh. I know where this is going, but
Because
no,
you know what your name
I'm
implies,
not.
right?
Yeah, I do know what the name implies.
Okay. Why did you choose that name?
Specifically for the name, I chose it a while ago based on some political things that were going on, and I wanted to use it more of like a satire because my political views don't really align with it. So, I mean, to each their own, I guess.
Okay. I would suggest changing it. If you don't hold those views, I would suggest changing it.
Okay.
People will just assume you're a Nazi based off of it.
Oh
Perhaps
yeah,
reasonably.
I've been seeing the comments on here.
Yeah, so like
scrolling by.
if that's not the way that you want to be like, if that's not the way that you want to be viewed, then I would suggest changing it.
Okay.
Right.
Yeah. Well, I appreciate your time, sir. Thank you.
All right. Good luck. I hope that he's being honest about that. I suspect he's not, but hard to say. He has Germany in his profile, even though he's region locked to the U.S., which is interesting. His name was Black Knight or was Black Sun Crusader, which is like a Nazi thing. From a matter of thought, with the $2. So you can see electricity without an atmosphere? Well, no. You need something to emit light, right? If you have a vacuum, what you can see, like if you have an actual pure vacuum, you won't see anything, but electrons will still flow. The only reason why you see anything with the when you're seeing like a spark, is because it's hot. You're making gas hot, and so it'll emit light as it cools, or it'll emit light thermal radiation as a result of being hot. And then the other thing is the electrons are recombining with atoms that have been ionized. And so that produces light. But if those atoms aren't there because it's a vacuum, then we won't see any light. Hopefully that helps. All right, let us, just gotta double check something. Yeah, I think that's actually a good point. I don't think that, oh, wait a minute, hold on. Hold on, I don't wanna. Like if you actually don't hold those views, you should change your name. Like that's just bad. If you do hold those views, then I guess that makes you kind of shitty. And by kind of shitty, I mean like exceptionally shitty. So, but yeah, so something that perhaps wasn't clear to you, Black Sun, just because we didn't get into it, I think that biological life starts at conception. I'm still very pro-choice. So, yeah, that might inform your position, but anyway, try not to dogpile. If he's genuine, he'll change his name. If he's not, then you know he's not, and he'll just be telling the world that he's that he has like shit views for the rest of his time on TikTok. So like, yeah. So the question is, when is like a new biological organism? When does a new biological organism exist? A new biological organism exists like that happens at conception, of course. Of course, there's no life is not a life is not a single thing. Of course, the sperm and the egg are both living cells, and so it's not like you have non-life giving rise to life. It's just that you have a new, unique combination of DNA when conception happens. All right, so the guest box is currently empty, which means that all of the MAGA have run away scared and embarrassed, I guess, which is, you know, egg is not living. I mean, it's a cell. How is it not living? Am I just being dumb? Yes, an ovum is a living biological cell. Life starts at Luca, there you go, true. All right, well, life starts at 40, also true. I guess all of the MAGA have been defeated. Oh no, Trump is awesome is back. I imagine that this is a troll, but we'll bring him up. We'll bring him up just in case. Trump is awesome, how's it going?
Hey, Dr. Blitz, how you doing today?
I'm doing all right. Trump is awesome. Are you MAGA?
I'm not. It's ironical. I apologize. I just wanted to actually talk about some physics, if you wouldn't mind.
I wouldn't mind. That's not for today. You got to come on Tuesdays or Wednesdays.
Okay, well then, my apologies to that. I got something pretty cool going on. It's actually on Zenando.
No,
so
don't do that.
Able to take a look. No.
Don't do that.
Well,
I
have it submitted. Listen, I have it submitted for review with the university, and it's in process. It's been.
Have you submitted it to a journal?
So yes, I am in the process of that right now.
Which journal did you submit it to? I know, he's, when you're off the app, I can't hear you, and I think he knows that. I think he's looking.
Sorry, my apologies. I thought it was APS at first. That's the one I was going to
APS isn't a journal. You should submit it to Physical Review, one of the Physical Review journals.
There was one that I was looking at. I've been waiting on a endorsement for a few months. And
you don't need an endorsement to submit a paper to a journal.
Well, I'm going through the ARXIV.
You don't need to do that to submit to a journal.
No, I know. I want to get it. I want to get it peer reviewed. I mean, that's the ultimate.
So then you have to submit it to a journal.
Is that the best? Is that the best route
Archive is
you
not
would
peer reviewed at
suggest?
all.
No.
No, it's a preprint. It's a preprint archive. There's no peer review there.
Okay, so journal would be the route you go. Now,
Yep.
I have a model, I have a prediction, and I have the
Then submit it to a journal.
covariant theory kind of worked out. Yeah, no, I understand.
But I don't
it's actually
review- but-
thermodynamics.
Unless a journal asks me to review a paper, I will not. It's a
Yeah.
blanket policy. So I'm gonna let you go. Trump is awesome, but good luck. We have no more super chats, no more guests. I guess we've defeated all of MAGA. MAGA has been defeated. You heard it here first, folks. I just want to double check something. Sorry. Why do I keep getting emails from? I hate that. Oh. Nice. Okay, so let's change topics then. Let's change to the one that everybody likes for some reason. I mean, I know why, it's fun. And then I gotta change the titles of various things. Give me 1 sec, we'll let people stream in now that we've changed topics, and then we'll bring up some guests because we already have one. I just have to change the names of things. All right, let's bring up tick clock time. Tick clock time, how's it going?
Good. How are you doing?
I'm doing okay. Tick clock time. Do you believe in God?
I do believe in God, and we did the Abrahamic Accord in 2015, man. I mean, atheists, you guys are in danger right now.
We're in
the
danger.
Abrahamic people.
Why am I in danger?
Of course, the Abrahamic people are unite themselves to destroy atheists from the existence here on Earth.
Oh no!
What do you think?
Oh no! I'm in danger.
Yes, you are in danger, sir.
Oh
no! Your people.
My people are in danger. Danger, Will Robinson. Danger, Will Robinson.
You guys killed Charlie Crick for no reason. You guys hate trying to kill Trump.
Who's
for
Charlie
no reason.
Crick?
You atheists trying to kill us because we are religious and we are the most majority people.
Oh no, you're so measured.
Yes, sir. And we will send you to other planets. I mean, CERN. I mean, 2030 is the last day for you guys.
You're gonna send us to other planets.
Of course.
How do you feel about the Wehrmacht? Tick clock time.
What did he say?
How do you feel about the Wehrmacht?
What?
It's a pretty basic question. How do you feel about the Wehrmacht?
I don't know. Who's Wehrmacht?
Wehrmacht?
Wehrmacht. Who is that?
It's the name of the German army?
German army. What does that to do with?
It's just a question.
The Abrahamic.
How do you feel about it?
Bro, come on. I say the Abrahamic according.
It's just a question. I don't know why you can't answer the question.
I don't know what that is. I don't know what that is. So
okay.
Explain.
Good. I'm glad that you don't know what it is. So why are you gonna kill us all?
It's not about killing. We will because we are the majority people here on Earth. We are about 7 billion.
Yep.
Yeah, 7 billion.
Well,
so
no.
atheists,
There's not 7 billion Abrahamic people on Earth.
Yes.
No,
Christianity.
not even
I mean,
close.
Christianity, Islam, and Jewish.
How many Jewish people do you think there are?
I don't know, maybe 500, 200 million. And
So there's about 2.5 billion Christians, about 2 billion, and these are rough numbers, but about 2.5 billion Christians, about 2 billion Muslims, and so that adds up to 4.5 billion. So you think that there's 2.5 billion Jews?
No, I don't think Jews are so many more than 200 million.
Okay, so you said 7 billion Abrahamic faith people. So there's 2.5 billion Christians, 2 billion Muslims. That's 4.5 billion total. Yeah. So how'd you get the 7 billion?
Okay, 4. Okay. I'm wrong with that. But we still the most majority people here on Earth, and we have the right to guide people here on Earth. Like
Why
we
do you have
did.
the right to guide people here on Earth?
because of the commandments from God himself. He gives us for that.
Which commandment says you have the right to guide people?
The tablets. I mean,
wait,
the first
which
tablets
commandment?
here.
Which one? Which commandment?
I mean, you have the First Testament, the Second Testament, and you have the Last Testament. So
sorry, guys. Sorry. One sec. I need to turn on a noise gate because there's a leaf blower outside. that's what all of that noise is. So apologies for that. I'll fiddle with that. But anyway, yeah, none of the 10 commandments says anything about having the right to guide people on Earth. That's not really a thing.
yeah, exactly. Yes.
Yes, exactly. You're wrong. I agree.
No, I'm not saying that you're wrong, but that's our commandments from God. You guys don't believe in God.
Which commandment says that you need to?
Listen.
No, please. Why can't you just let me ask the question? Why didn't you just let me ask the question? Which commandment from God says that you have to guide the Earth?
I mean, from the First Testament to the Last Testament.
Wait, so there's no particular commandment? Is what you're telling me?
People. Okay, so if Jesus come back, Jesus is on the way. By the way, that's why Trump is making it clear for him. Trump is not the Messiah, but he's the one who will open the gate or the Stargate.
Are you sure?
Of course.
Because people have been saying that the Messiah is coming back for like 1,000 years, and he's never come back.
1,000 years, bro. It's about 2,000 years that he's going back to heaven.
Oh, you're right. People have been saying it for 2,000 years, and he's still never come back. People have been wrong every single time every single time anybody said Jesus is coming back, they've been wrong.
No, we say, even Muslims say, in the end of the times. And we observe that we are also in the end of the times through many signs.
Okay, what are the signs?
The signs, for example, we're gonna put the Jewish people in the Holy Land. I mean, in the Palestine or Israel.
What are you doing to the Jewish people? You're putting them there?
Yeah, we have to. Yeah, we did put them there. Christianity and the Muslims in the 18th century.
Well, look, I hate to be that guy, but the Muslims don't seem very happy that the Jewish people are there right now.
No, it's part of. Listen. It's part of.
Like, I hate to be that guy, but like that's a historical point of contention.
No. Listen, look. You know that we Christian and Muslims, we don't allow Jews to live there because of commandments from God to kick them out. So when we did put them there back, it's for a reason, and it's also for a sign for two people, Antichrist and Jesus Christ.
Well, so the Muslims don't believe in Jesus coming back.
No. This is our belief. Maybe it's wrong, but we fight for that, and it's our goal. But you atheist, you're not so many people here on earth, so you are in danger. You cannot
We're in danger. Danger, Will Robinson.
I mean, you have nothing to defend. You have nothing to command here on earth as an atheist. But we, as religious,
we have nothing to command. What about China?
No,
we have China.
Exactly.
We have China.
We will kick China after Iran. China, we will catch China in Persia. Look, our project is clear. China and Russia, they're gonna be destroyed in Iran, in Persia, and that's what we're playing for. We don't. Hey, do you think we fight with Persian people, like just Persian people? There is no China behind that. Yes, that is China behind Iran, and there, where we will destroy Iran. I mean, China with Japan. You see what I'm saying? This is Donald Trump, and this is our religious perspective and system and politics.
It sounds like sounds delusional.
At least it's not. I don't care about your feelings, man. But at least we are the most majority people here on Earth. You can't fight with us. You can't fight against 4 billion people.
I don't need to fight with you. You guys fight amongst yourselves.
That's politic, man. You have to fight, man. At the end, but you cannot fight. But you have to fight. But at the end, you lose. At the end, you have to do something that we will destroy you. You see what I'm saying?
You know, you'd say that, except the number of atheists is growing, right?
Is growing.
Yeah.
But that's why Trump is there. If Trump was not there, maybe it will grow more and more and more. I agree with you with that. I agree with you because of media, because of things that you guys
So how are we losing?
Because Trump is here right now. Trump is the Messiah. Trump is the king right now. Trump is the destroyer.
He's a troll. He broke.
No, I'm not trolling, bro. Come on, man. I'm not trolling, bro.
Why would you call Trump the Messiah?
What I mean. No, I'm saying the Messiah because he will the reason to open the gate.
He's definitely a troll. Let's talk to Michael. You had me sold though for a minute there. Michael, how's it going?
Hi. I wanted to ask you a question about a different topic. Is that okay?
Yes, mildly on topic. What's it about?
What is your stand on the Israeli-Palestinian situation right now?
I think that it's like horrible. I think that Israel needs to, stop doing like apartheid in the West Bank, stop doing, wanton destruction and arguably genocide in Gaza. I think that I don't know what the solution is. I think that that's something that they need to figure out. Like there needs to be some sort of deal worked out, whether it's one state, two state, whatever they want is what they should do.
Okay, thank you. That's all I wanted to ask.
Okay. Did I just hit the Islamic hornet's nest? I don't think so.
Oh, sure.
Musician Theory, how's it going?
Hey, it's going good. How are you?
It's going all right. Musician Theory, do you believe in God?
Yes, I do. I am a Catholic. I was born Catholic and raised Catholic. And I'm here to have a respectful debate with you.
Okay, yeah, works for me. So you believe in God, that's good. I don't. Why should I believe in the God that you believe in?
First question I want to ask is, why don't you believe in God? That's why I want to hear.
I haven't really been given any good reasons, to be honest.
Okay.
Like, a lot of people have tried to give me reasons before, and none of them seem very good.
I get what you mean. Like, what reasons have other... Because this is my first time tuning in, so I thought...
Yeah, so people will say, like, look at the trees a lot, and I'm like, okay, why should the trees mean that God exists, for example? And then, like, there's other more sophisticated arguments. I just haven't been convinced by most of them, by any of them, really. And then, of course, there are also, there are arguments against the existence of, like, the Christian God in particular. I think that probably the Christian God is very easy to move away from. Mm-hmm. Just because, like, it doesn't really make sense.
Yeah.
Right? So, like, what do you mean? What do you mean that this God is, all loving, all knowing, and yet let a child abuser into the Garden of Eden? Like, what? Why?
Okay. I will give you some of my reasons why I personally believe in God and such. So, a few years ago, I had some of the worst mental health and other stuff back then. And there were times where I felt like I just needed to end it. And I've had multiple epiphanies. Like, so I went to this thing called NCYC. It's like a youth conference thing where like a bunch of Catholics get together, and I felt...
So, musician theory, not to cut you off, not to be rude, but people have told me their personal experiences quite frequently why they're religious, and I can assure you they're just never compelling. Because there's something that happened to you. Whatever happened to you, I'm sure it was meaningful. I'm sure it led you to a spiritual, whatever it might be, that is helpful and meaningful for your life. But like when you tell someone about your own personal experience, your own personal religious experience, it's like telling someone about a dream you had. Like your dream could have been the coolest dream in the world, but when you tell somebody about it, they're gonna be like, okay, well, it's like they won't care. And so, generally I find personal experiences to be completely uncompelling. If you could make a personal experience happen to me, like if you could snap your fingers and make it happen, then sure. But then that would be my experience, not yours. So if you have something else, some other reason why I should believe, that'd be great. But I'm not here to debate your personal experience.
Yeah, I get what you mean. But all right, I know what you just said I'm not here to debate. I'm gonna give one personal experience from why my life, just like as an example, and then I'll build off to that if that makes sense.
I'd rather you not. I'd rather you just build off of the just give the, rather than giving the story, just give the reason why I should believe.
Personally, I feel like you should believe in God because once you put your faith into God, you will be able to see things. Sorry, I'm really bad at words. I'm not the best at it. So if you put your faith in God, he will put his faith in you. That being said, if you bring like personally, I feel like if someone is just a good person, they will go into heaven, and that's what I was taught in my Christian views. And personally, I feel like if you put your faith in God, God will. I'm sorry, I'm just got distracted by chat.
It's okay. Don't read the chat.
Yeah, they're just messing with me. Yeah, if you put your faith in God, He will put His faith in you, and once He does that, you will be able to do anything you want in your life.
But the question is by saying that, you're assuming that God exists to begin with. But if I don't think God exists, why would I think that God would put His faith in me if I put my faith in Him?
All right, you got a good point there. So here's another thing that comes to my mind, like an atheist, because I felt like going away from Christianity a few times, and one thing that kept popping in my head is how could all of this happen? Like, what I mean by that is, like, how can excuse me, how can the universe just start? How I feel like there has to be some kind of maker, whether it be my God or something else. I feel like there has to be something that created everything.
How do you know that there was a start to begin with at all?
Well, the Big Bang, for example.
I don't think the Big Bang was necessarily the start.
What do you think was necessarily the start?
I don't know if there was a start.
Okay. Well, there has to be a start to everything.
Well, that's not true, unless you think that God had a start.
All right. Well, personally, I feel like I know I keep saying that and you don't want to hear about my personal stuff, but I say that because, like, I'm trying to get my thoughts together.
No, that's fine. I like,
okay.
what bothers me, and because it just ends up being a waste of time, is like somebody will like talk for 15 minutes and then they'll be like, and about like something that happened to them when they were like 19 or something, and they'll be like, and it's boring, and it never has
like
the intended effect.
On and on, you know?
Right. And so, but if you just want to say personally, I think, and then give a reason and not just like a personal experience, that's fine. I don't care.
Yeah, so I feel like something had to create all of this. Like, whether it be God or another supernatural being.
But how do you come to that conclusion, right? Like, could it be... So, you believe that God has existed forever, right?
Yes.
Okay, why couldn't the universe just have existed forever?
Because scientific evidence, I know I'm getting sciencey with Christianity, but I feel like if you look at both, they kind of coincide. And sorry, I'm getting my
You're fine. You're fine.
I say sorry a lot.
It can be. I understand that this can be nerve-wracking, so don't worry about it.
Yeah, there's just a lot of people in here, so I'm not really used to that. I mean,
you're totally fine. Nobody's. If people are bad-mouthing you, if people are talking shit about you in the comments, it's because they don't understand that hurts people's feelings.
Yeah.
So, like, comments be nice.
In a way, you could think of. So we're in a universe, correct?
Yep. I would hope so.
Yeah. If you think about it, the universe could be in a way of being God itself, if you think.
I mean, okay. What you're describing is something called pantheism, which pantheism is like, in some sense, it's a kind of theism, but it's not like it's almost indistinguishable from atheism itself. And so, like, that's why I generally don't argue with pantheists. Like, if you want to hold the pantheist position, then you can, and I generally don't argue with you because it's usually just a debate over definitions. Like, can we define God to be the universe? If you can, then, and that's, debating over definitions isn't very interesting. But, like, look, you're not a pantheist. You're a Catholic, right?
Yeah.
So it's a little bit more than that for you. And so, like, we can just make this super concrete. It's my understanding, and correct me if I'm wrong, but it's my understanding that in order for Christianity to make any sense, original sin has to exist, right?
Yes. Caused by Adam and Eve.
Right. Now, in order for that to be the case, it seems like that means that, God made the Garden of Eden, God made Adam and Eve, put them in the Garden of Eden. They were like really, they didn't know anything. They were like maximally innocent, right? And then God let in a child abuser, Satan, to go hang out with them into the Garden of Eden. Why would he do that?
I'm gonna be honest. I'm not a perfect Catholic. I feel like no one's perfect, obviously.
You don't have to be perfect, but it sounds counterintuitive, right? Like, look, there was a guy, an angel even, Gabriel, I think, who was guarding the gates of the Garden of Eden. Why did Gabriel let Satan in?
Wait, why did Gabriel let... Wait, never mind.
I mean, Satan wasn't always in the Garden of Eden, the serpent. He went into the Garden of Eden. He wasn't made in the Garden of Eden. He entered the Garden of Eden. So why did God's bodyguard, why did they let him in?
I'm gonna be on, I honestly don't know. I'm gonna be real with you for a sec. I don't know.
I mean, it's fine to not know. All I'm saying is that it's these kinds of questions that, and that one's, it's not the only question that I have, but it's those kinds of questions that make me think that maybe Christianity isn't right.
Yeah. I have another question for you.
Yeah, sure.
Do you believe Jesus walked this earth?
Yeah, probably. At least some guy named, Jesus is the Hebrew name would have been Yeshua, which could be translated into English as Josh. So some guy named Yeshua probably was wandering around in first century Judea. And, plausibly he was executed. That's believable. Plausibly he had a bunch of people who were following him. That's believable. I'm not so convinced on the whole miracle stuff.
All right. Another thing that makes me believe in the Bible and such is so many of the stories from the Bible have come true. Like, for example, Noah's Ark, from what I heard, it's been discovered, in a way. Like, they're finding the ruins of it.
Unfortunately wrong.
Am I?
Yeah, so there have been, throughout the centuries, there have been tons of people who have made the claim that they found Noah's Ark. Not a single one of them has been scientifically verified.
Okay.
The most recent one was, they saw a mountain that was roughly rectangle-ish shaped, and they're like, aha, this mountain is Noah's Ark. But no archaeologists no archaeologists, no geologists, no historians, none of them are agree with that.
Yeah. And there's another one about how I don't remember their names because, like I said, I'm not the perfect Catholic or anything.
It's fine.
But God told them he was raining fire onto a city, and he told them, don't look back or you will turn into salt. And she looked back and she turned into this sculpture of salt.
Yeah, I know this one too.
So you know what I'm talking.
Yeah, you mean Lot's wife.
Yes, Lot's wife.
Yeah, let me pull up the picture, because there's a picture of this pillar of salt that is apparently Lot's wife. Let me just pull it up for you really quick.
But from
then we can look at it together.
There was some kind of DNA found within that sculpture, whether it be Lot's
sculpture. It's not a sculpture. It's a rock. It's made of salt, right? And let me see if I can get up the exact. There's it has a particular name. Is it Lot's wife pillar? I know it has a location. I just want to find it really quick.
Yeah.
I'll just go to one of these. I just hate these websites because they tend to be really preachy, but maybe they'll have the name. So you're talking about this, right?
Yes, correct.
Okay. Now, the location here, and we can verify this, so it's been a while since I've looked at it, but maybe they'll include the location. This is like a 40-foot tall or 40-foot tall, not even statue. It's like a 40-foot tall, pillar. It's not the size of a person, right? So
but
it can't be her turned into salt.
How do we know that? Because over how long, let's say like 1,000 years or so, that the Earth doesn't erode.
If it eroded, it would get smaller, not taller.
Excuse me. Sorry about that.
Sorry, it's 65 feet tall.
65.
Not 40. So like it's not a person. But the things that you're mentioning are things that are mentioned by, or things that are brought up by a fellow who, you know, he's no longer alive, but his name was Ron Wyatt. You know, maybe you've heard of like the chariots found in the Red Sea. Yeah, chariot wheels. Okay, yeah. That's also, so all of this stuff is made up. And like none of the scientific community agrees with any of it. Like the chariot in the Red Sea, because I can show you the picture that I'm talking about. The Red Sea. You are thinking of this. Kind of blurry, but you're thinking of this. Oops.
I can't really see that.
Come on. There you go. You're thinking of this. That's coral.
Mm-hmm.
Right. In fact, actually, the Egyptians didn't have chariots at the time when this allegedly happened.
Sorry to interrupt you, but that one I didn't really believe too much in it because, like you said, it looks like coral and.
Yep.
I don't want to be logical, but the Pillar of Salt.
It's 65 feet tall. How is that a person?
I got words in my head. I just don't know how to describe what I'm trying to say, if that makes sense. Like,
I get it. Well, look, so there are a bunch of people waiting in the guest box that, you know, if you want to step down, I don't have to let you go, but if you want to step down and so you can listen to the kinds of arguments that I make, we can always bring you back up at a later date if you want to talk more.
Yeah, I'll be able to step down. I just wanted to see what I could say.
That's totally fine.
Yeah, but you saying like the personal stuff, like I feel like I could say more if I had my personal beliefs, but if you don't,
no, I mean, look, you can have your personal beliefs. The thing is like, okay, let's say that you tell me, you know, your girlfriend was hit by a car and she was bleeding out, and you prayed over her and miraculously her bleeding stopped. I'm like, okay, cool. Why should I believe that this happened? Why should I think that this happened the way you thought it happened? Why should I think that this involves God? Like, you know what I mean?
Yeah, which I get your side of it, like the way you're thinking. Like, oh yeah, this could have happened several different ways.
And the other thing is that, like, people have religious experiences of all faiths, right?
Oh yeah.
And they can't all be true. Mm-hmm. So, I don't know. They're just not very compelling to me. But look, I'm going to let you go musician theory.
Yeah, I get. I hope
good
you
luck,
have
okay?
Good day.
Likewise.
Yeah, thank you for a good, respectful debate, and I respect your view on it, and I hope you can respect mine.
I can. Take care.
All right.
Sweet guy. I think he was nervous. I think he was super nervous, which I get. I understand being nervous 100%. Let's bring up our next guest. Just going to read a few super chats first. From Necto at Night with the $2.22. Your title has the wrong date, FYI. Good catch. I have fixed it. From Brian Peck with the $2. Bro just discovered the claims of Ron Wyatt. Yeah, I mean, like, look, we do our best, okay? I feel like I've spoken with Superstar recently, didn't I? But let's bring up Superstar because I think that they've been waiting the longest. Superstar, how's it going?
Hello.
Have we spoken recently? I'm doing all right.
I don't think so.
Okay, so Superstar, do you believe in God?
I do.
Okay, I don't. Why should I?
So, I want to try to give you an argument that I haven't seen you or any other atheists respond to.
Sure.
So, first I would just want to say my definition of God. So that would be a unmotivated or what do you say? Yeah, unmotivated or force that's not caused by anything else. So
does it have a mind?
Well, not necessarily.
Oh, well then, like, I can be an atheist and think of an unmotivated force that's not caused by anything.
What would that be? for example?
Could be like gravity.
Well, that's caused by the expansion of the universe.
No, gravity is not caused by the expansion of the universe. The expansion of the universe is caused by gravity.
Actually, no, that's not. Well,
sure it is.
Well,
it's a
anyway,
result of the Einstein field equations, but that's neither here nor there. The point is that, like, look, if you're talking about something that could just as well be just like a natural thing without a mind, like a, you know, like a totally physical thing, then like it's just, you can be an atheist and believe in that.
Okay, well, okay, absolutely. Well, I just want to see this argument real quick.
Well, if the argument is for that thing, I grant that that thing can exist. I just don't think that that's God. I think you can be an atheist and believe in that thing.
Okay, so what's your definition of God?
Some sort of mind that's the foundation for reality.
Some sort of mind? Well, okay.
Because it has to have a will, right? Otherwise, it's not. Like, if it doesn't have a mind, it's not. It's just like a thing.
Well, we're getting into like
it's just a definitions game. But if the thing that you believe in doesn't have a mind, then this is a game of definitions, not like a substantive debate.
Okay, well, I suppose a mind would be a explanation for this, and I would think that a mind for, you know, I haven't given my argument yet, but a mind would be a very logical explanation.
Well, would the thing that you believe in, does the argument that you're going to offer imply that this uncaused force has a mind? Because if it doesn't, then the argument's going to have no force against an atheist.
Well, yeah, it does. It does provide a rational explanation as to why this force would have a mind, because it disables any other.
Okay, yeah, go ahead. Go ahead then. That's fine.
Okay, so say that you're holding something. Then I would ask, what's it held up by? Well, you would say your arm. Well, what's your arm held up by? Well, your body. And if you continue, you would get to like.
Are you familiar
my
with the
body's held up by
word?
the chair.
Are you familiar with the idea of horizontal causation or grounding relations?
No, I'm not familiar.
Or maybe it's vertical causation. This is what you're talking about. This is a very well-known argument, by the way.
Okay.
But go ahead.
So, if you continued asking that question, what's it held up by?
Yeah, you end up with like the Earth.
No, yeah, maybe you would stop. No, you wouldn't stop there, actually.
Well, yeah, if you're asking what is that held up by, what is that held up by, eventually you just get that it's held up by the Earth, and then the chain terminates, because the Earth isn't being held up by anything.
Well, it would be the force of the Earth. So the force of the...
So if the answer for why is the cup being held up, if the answer to that, or if the answer to the question what is holding the cup up is your hand, what is holding your hand up, your arm, well, then the answer at the end of the day, once you go all the way down, is the Earth. The Earth is holding up my feet, which is holding up my body, which is holding up my arm, which is holding up my hand, which is holding up the cup. That's the end of the chain.
No, I don't. Well, I guess this is a disagreement, because I don't think the Earth is. I think the Earth is holding up by, you know, the gravitational pull, and
that's not holding the Earth up.
That's what keeping it. That's what's keeping.
So now you're equivocating between the thing doing the holding up and the mechanism by which it's held up. Right? Those are different things, because you didn't say that, oh, well, it's not your hand that's holding up the cup. It's the electromagnetic repulsion, or it's the electromagnetic force that's holding up the cup. That's not what you said. You said it was your hand that holds you up. So if we're using the same notion, then either the hand is what's holding up the cup, or in which case the Earth is what's holding up the cup ultimately, or your hand isn't holding up the cup. The electromagnetic force is holding up the cup in the same way that gravity is kind of holding the Earth together. You can't have it both ways.
I see. I suppose that's true. Yeah. So you can't say that like the Earth is being held together by gravity.
Sure it is.
And so that's what's holding up whatever is, you know.
No, gravity is not the thing that's holding up the cup, though. That's what's holding the Earth together. That's what's giving the Earth form. But that's not the thing. But it's the Earth that's holding up the cup. It's not the Earth's form that's holding up the cup, it's the Earth.
I mean, yeah, that's true, I suppose. Yeah. Is this like usually like I don't know. All right, well, thank you, I guess.
Okay. Thanks for being here, Superstar. Take care. All right, let's bring up Dolev. Oh, actually, we have some guests on Discord. I'm sorry. Let's bring up Roger. 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 Roger, you got to unmute yourself and then you can talk. You're on the show.
Hello.
Howdy, how's it going? Roger?
I'm here.
Great. Roger, do you believe in God?
Can you hear me?
Yeah, you're a little bit quiet though. If you could talk a little bit closer to the mic, that'd be great.
Very well. Thanks for asking. Well,
Great.
I'm Mexican. My English is intermediate level.
I think that you'll do fine. Do you believe in God?
I don't believe in God. I'm absolutely convinced that God exists, and I can prove you.
Okay, so that's a yes. Okay, what's the proof?
Well, let me tell you something which, throughout human history, has been
Roger, I'm gonna have to let you go. Between the combination of the language barrier and the bad audio and the connection, it's just not today. TF, how's it going? You're on the show, TF. Gotta unmute your mic. Hi, kitty. Why? TF. Okay, TF doesn't want to join. All right, let's bring up a guest from TikTok. Let's bring up Dolev Vider. Or Wider?
Yo, hello.
Dolev, how's it going?
Good. How are you?
I'm doing all right. Dolev, how old are you?
I am 18, 2008, May 19.
Okay, cool. Dolev,
I just have a high-pitched voice.
That's fine. It's fine. I have to ask. So, do you believe in God, Dolev?
Yeah. I do to a certain extent, but I do have some objections to what do you believe was before the Big Bang? What do you think created the Big Bang?
I don't know.
So do you think it's reasonable to kind of have is it reasonable to think that an intelligent mind was physically binding the Big Bang to create the universe?
No, I don't think that's reasonable.
So what do you what's your idea of what was before, if you had
I don't
to
know.
have one? Okay.
My point is we don't have enough information. We can't establish it yet. This is something that people are working on, but we don't have enough information yet. And so we should just say, I don't know, because we don't know.
Okay. That's fair. So another thing I have is, sorry, one sec. I'm just nervous a bit.
It's okay.
I kind of blanked. One sec.
It's okay. Breathe. I promise I won't bite your head off.
Oh, thank you. Damn it. What was it? Kind of blanking.
Let me prompt you. So what is the God that you believe in?
So I'm Jewish. So
I fucking knew it. I knew it at 11 in high school. I'm Jewish too, by the way.
So, yeah, it's a very Jewish name.
Yeah. So why do you believe in the God? Do you believe in the God of the Torah, or is it more like you kind of believe in a vague notion of God and you kind of connect that to the Judaism that you presumably practice?
Option B, yeah.
Okay, so why do you believe in this vague notion of God then?
Because I feel because we don't have an explanation to what was before the Big Bang, I don't like having uncertainty, and I think of the vast majority of people also don't. So just if that's the only explanation that can be given as of now, then that's probably why I'm choosing to believe in it.
Okay, so look, so I understand why you might believe in it. The question is it a good reason, right? So I agree that people don't like uncertainty. People don't like not knowing things. So people will believe lots of things, even if it's not a good reason. Like, think about, the ancient Greeks. They believed in Zeus. Why did they believe in Zeus? Well, they couldn't explain why there were thunderstorms and lightning, and the lightning kind of looks like a giant spear, and people throw spears, so maybe there was a guy in the sky that was throwing lightning bolts at the ground, right? And so that's so people believed in Zeus, even though there wasn't a good reason to do so. They just didn't understand it. And so I can understand that. It just doesn't make it a good reason. And like the one other thing is that you're right, we don't know what was before the Big Bang, if there even was a before, but there are plenty of options that we have that are scientifically viable. So it seems like we don't have to choose the God explanation when there's other possible explanations that we can rely on.
What, like, I'm just not fully like sure about what the
do you like
Dolev,
do you like reading?
I do.
Okay, there's a book. There's a book. It might even be on audiobook now. It's called Battle of the Big Bang. Okay. It's written by a physicist and a science communicator. It's very good. I'm not shilling for them. I just really like the book. And the whole story of the book is basically first a brief history as to where the idea of the Big Bang came from, which was about 100 years ago, and then it goes into over the last 100 years the kind of the history and the different ideas that are brought up about how to explain the Big Bang scientifically, like what it was, what caused it, what are the possible explanations. And in the book, it goes over 25 different explanations, like scientific explanations for what caused the Big Bang. Yeah. All of them, it depends on the person, of course. Some of them will seem more reasonable than others, depending on what kind of things you think are reasonable. But the point is that there's so many. There's so many different explanations. So, and I could briefly go over like one or two, but the point is I wouldn't do it justice.
Okay, yeah. I'll look into that book.
It's a good book. And I don't think it's that expensive either.
Yeah, for sure. I remembered the second thing. So,
sure.
Like, isn't it kind of like insane how many exoplanets do we already know of? Like
6,000 or so.
6,000. And like none of them so far have had like substantial evidence to there being life on that planet.
So that's true. But we also haven't looked very hard, right? I mean, like, okay, so obviously there's life on Earth. We've sent things to the moon. There's probably no life on the moon, like almost certainly, because there's not an atmosphere.
Yeah.
We sent a few probes to Venus, but they like basically melted in like a few hours. So we didn't really check that Venus has life. Venus might not have life. It probably doesn't, but it might. We didn't check very hard. Mars might have had life in the past. There's at least evidence of microbes, but we don't know of any life that exists on Mars now. And that's like basically the only places that we've checked, right?
Okay.
Mars, Venus, and the moon. We can go look. We can, like, when we're looking at exoplanets, it's literally a single pixel.
Oh.
Like, it's like we are not able to resolve exoplanets to see that there's like, to see if like we can see, life. Now you can do a lot with that pixel, with that single pixel.
What do you think that like once Nancy Grace, or I think that's the name of the
Nancy Grace Roman Grace.
Yeah. So how much do you think that's gonna advance us with like?
It'll help, but I mean, at the end of the day, these things are too small to resolve, smaller than a pixel, and so so what you can do is you can analyze the light that you get from them, like the colors and the frequencies of light, and you can use that to try to figure out like what the atmosphere is made out of, for example, if it has an atmosphere. And so that's useful information. And so you can make some inferences about whether or not life could be there. Like if you find oxygen in the atmosphere of an exoplanet, there's probably life there. Oxygen doesn't last very long on its own. But there are other compounds that you can look for that would be evidence of life, even if it's not oxygen breathing life. There was one actually that was a big deal recently. It was a sulfur compound, or like a potassium compound that they actually did find on a planet. It's not a surefire thing, but it's like a possibility of life. So what I'm saying is that we haven't looked very hard. And we have seen some evidence of life in some places, just not very many, and it's not very convincing.
Okay, so we have to do much more.
We have to do. There's more science to do. There's always more science to do.
Isn't it like crazy how like I seen like videos? It's like if Earth was like 10% closer to the sun, or 10% like further, and then if the rotation was 10% slower, 10% faster,
But 10%
there
is a
wouldn't be
lot.
life here.
Like,
Yeah,
okay,
that-
so you're right. That is true, roughly. I mean, it's actually probably closer to like 30 to 50% closer,
yeah,
30
I'm
to
just-
50% further away. But
Yeah.
so I know what you mean. But the thing is so you're right. Earth is compatible with life. Earth, as far as we can tell, is not a common kind of planet in that it has all of the right ingredients for life to happen. But the point is the universe is very, very big. So even if planets like Earth are not common, there's a lot of planets.
Too many.
So one of them was bound to be compatible with life. There's just so many planets that it was bound to happen.
One more thing. I don't want to take too much time from you. I have a question. Like, okay, so there's a standard on Earth of how life can be created. Like, what if in like other planets or galaxies, like species can adapt to different like environments than we can?
Yeah, then the things that we look for to find life will not tell us, will not pick up on that, right? And that's like a relevant thing to keep in mind. You know, it's hard to figure out all of the possible ways life could be. So the first thing to do is to look for life that's like your own. If you don't find any of that, then maybe look harder for other alternatives. But you know, it's easier to look for things that you do know than to look for things that you don't know.
So it's definitely like the idea is definitely there that like okay.
Yeah, it's definitely something that people are taking seriously. It's just a hard problem to solve. But people will look, and you know, so you said you're 18. You know, the Nancy Grace Roman telescope, when does it turn on? Did it already start?
I think September. I think it launches like early September.
And I think that it's going to be used to find
Dark matter?
Yeah, no, it's not doing I don't think it's doing a survey for planets. I think that's the other telescope. Anyway, the point is you're 18. I would bet money that you will live to see life found on another world.
Really?
You're young enough, yeah. I wouldn't be surprised if it was 30 if we found life within 50 years. I actually wouldn't be surprised if we found life on Mars. Yeah, I was thinking of Vera Rubin. I wouldn't be surprised if we found life on Mars within 10 years, actually.
Talking about when do you think I know that Elon Musk had like the prediction in like 2016, but like it didn't really pan out.
I just never believe anything Elon Musk says. But like I could see us doing it. It really depends on what the politics is. Like if the government wants to invest in science and exploration, we could be on Mars in 5 or 10 years, but the government doesn't want to do that seemingly. So
But isn't that like the thing with like SpaceX and Blue Origin is that like they're private sector, so you don't fully rely on NASA?
So SpaceX gets almost all of its contracts from NASA.
Oh.
So like they're just doing what NASA pays them to do.
Because I thought that like they were trying to be different like than the Apollo days that like when it just became
well, yeah, so
like irrelevant.
So the point of so in the Apollo days, NASA built the rockets. Now NASA pays Elon Musk to build the rockets.
Okay, so like Blue Origin and Starship is basically just like the products for NASA.
Yep.
So they don't do their own.
I mean, so Elon Musk also does Starlink stuff, so that's for his own stuff. But
Okay,
like they're a company that contracts, and most of their money comes from most of their contracts come from NASA. They do some other contracts as well, and they do some of their own stuff as well, but it's mostly NASA as far as I'm aware. But Delev, I'm gonna let you go. Hopefully I gave you some stuff to think about. Feel free to come back and ask some more questions at any time.
Battle of the Big Bang, right?
Battle of the Big Bang. And honestly, if you want to DM me on TikTok, I can shoot you the name of the book.
All right, thank you.
Of course. Take care.
Have a great day, Bella.
That kid, the kid can learn. Let's read some super chats and we'll bring up another guest. From A-List with the $20. Thank you so much, A-List. By the way, y'all, it is people like A-List and other supporters that really keep this going. The TikTok monetization for the science communication videos may be going soon. It's not clear. There is something happening at the beginning of next month, which may basically gut my monetization on TikTok, which would suck a lot. So it's people like you guys who support me through YouTube, who support me through super chats and things like that really help keep the ship afloat, if you will. So I do appreciate that. A-List, you say, such a great example of MAGA. Doesn't listen, can't control his outbursts, insults constantly, a walking Dunning-Kruger, an absolute tool. I agree. I absolutely agree. From I'm the Big Cheese with the $10. I or we define X as God. This is defining God into existence, God of gaps. It is like if I answered my algebra test with X equals God. Don't assert God, justify why it is exclusively evidence for God. Well, okay, technically it's not God of the gaps. God of the gaps is when you find an unexplained thing and then you say that God did it. It's not defining God into existence. But that's a minor nitpick. From Joe Max with the 729 AED. So I understand you believe in aliens. I think that they almost certainly exist, yeah. And let's double check. We have Videos Forever sent $5 on Buy Me a Coffee. Blitz, please tell me to get back to studying because I'm distracted by your lights. Go back to studying, Videos. Do it. Oh, that was 2 hours ago. Oh my god. He's been distracted for hours. Or she's been distracted for hours. Sorry. That's my bad. Okay, let's bring up Bape. Bape, how's it going?
It's going great.
Glad to hear it. Bape, do you believe in God?
Yes.
Oh, you there?
Wait, do you hear me?
Yeah, I can hear you now.
Oh, okay. So why don't you believe in God?
Because I don't find the arguments for God compelling, and I find the arguments against God non-compelling.
Okay, my English is not great. What complaint means?
What?
What?
What? I didn't hear what you asked. All right, babe, I'm gonna let you go. There might be too big of a language barrier there. Let's bring up Luca. Why does my arm hurt all of a sudden? Luca, how's it going?
Good, you?
Luca, what year were you born?
Huh? 2014, but wait.
Bro's 12. Bro's legit 12. A fetus even. It's my left arm, but it's like a muscle in my left arm, like right here. It's very unpleasant. All right, let's bring up Cord Shannon. Cord Shannon, you were on the show.
Oh, hello.
Howdy, Cord Shannon. Do you believe in God?
Yeah, I do.
Okay, Cord, why should I believe in God? Because I don't.
Good question. I didn't really have anything prepared for this. Could I actually just tell you what I was hoping for in this call?
Sure, go ahead.
Right, I really enjoy your videos and your work on physics. It's really, it entertains me and helps me understand a lot better on what I want to do in physics.
I'm glad.
And I was wondering if you have any textbook recommendations for a college freshman starting out.
Not today, but I'll be nice.
Not today. All right.
If you're a freshman in physics, use the textbook that they assign you. It'll be a good one. There's only like 2 or 3 textbooks that they ever use, and they're all good.
Right. All right. I'll explain you my situation right now. The textbooks that they provide have a ton of errors and AI generated stuff.
Oh.
I'm being honest. It's
okay.
Horrible.
So usually I wouldn't keep you up, but there's a book called University Physics by Young and Friedman. It's the book that I learned out of. It's the book I've taught out of. It's very good.
Friedman. All right.
Yeah.
Oh, I love that. Thank you so much.
Of course. Good luck. I am afraid if the textbooks that he's using have like all this like crap wrong stuff. That's really bad. From Pensive with the $20 for crab hands. And from Joe Max with the 729 AD. So how sure are you that God is not real? Not 100%. Yeah, I'm not 100% about a lot of things. But yeah, appreciate the super chats, guys. I appreciate you guys supporting me. I'm looking into need to get a new car soon, so that's fun. So yeah, let's bring up another guest. Let's bring up Brian. Brian has an anime profile picture, so Brian must be a skilled debater. Is it true, Brian? Are you a skilled debater? Because you have an anime profile picture.
No. I'm a theist, but I actually believe there's like no successful evidence for or against God. Well, not evidence, argument specifically. Maybe there's some stuff that's slightly probability raising for some kind of like theistic hypothesis, but the same goes vice versa for naturalism. I requested up because I have like a question about like a specific thing within philosophy of physics, which Joe Schmidt mentions in a book but never expands on. And
Sure, I might not know about it though, but yeah, sure, go ahead.
Yeah. Okay. So basically, within his book, like existential inertia and classical theistic proofs, he talks about like a position within philosophy of physics, which he refers to as atemporal wave function monism, where basically the position admits like an aspatial, atemporal yet physical entity. And I was curious, like how would one define physical entity then if it permits like entities that are neither spatially nor temporally extended?
Yeah, so this is a question about how you define physical. In this case, the thing is describable by a formula or by an equation that in this case it would satisfy the Schrodinger equation. And so, some people would define physical as something that obeys a law of physics, and in this case it would. The law of physics being the Schrodinger equation. It's perhaps not satisfying though.
I didn't hear you. I got a call. I didn't hear you. I got a call.
So it depends. This is a question about how you define what something physical is, right? And so some people would define something physical as if it obeys one or more laws of physics, it's physical. If it's constrained by the laws of physics, it's physical. And so in this case, if that's the definition you're using, this atemporal wave function monism, this is an object, or this is a thing that is constrained by and describable by the Schrodinger equation, a law of physics, and so it would be physical in that regard. But this is a tricky business of trying to define what does it actually mean for something to be physical.
Yeah, I know, but when it comes to the laws of physics, you're not holding to like realism, but the laws of physics, because then they themselves would be physical entities.
Right. No, they are. You don't have to be a realist in order to recognize that you can describe things. If you can describe things with laws of physics, then that you would call them physical. That's just a naming convention, right? But look, I'm actually not sold. Like I don't think I have a good definition of what the physical is. Especially at the most fundamental level. Like trees are physical, but like, okay, what about like quantum fields? I think that there's problems with the way that we label these things at the fundamental level. It's certainly not supernatural though, or perhaps it's certainly not a theistic entity of some kind. So that's but the questions of how to define these things, it's a good point, and it's a point that I always bring up.
But regarding this specific definition with if it obeys the laws of physics, it's like a physical entity. Regarding that, well, if we take like an anti-realist approach, and let's take like a Humean, Lewisian kind of approach that says that the laws of physics are just descriptive summaries of physical.
Then that definition doesn't work, right?
Yeah, it's circular.
Yeah, I know. So like it just depends on depends on how you're cashing out laws. It depends on how you're like, and this is like, I'm not making the claim. Maybe Joe Schmidt has another notion of physical that he's using here, which is plausible, and I just don't know how he's defining it. Maybe he's made a mistake somewhere. I don't know. I'm just telling you that is one way that you could interpret it as physical things. But I'm not convinced that there's a good definition of physical. But I'm gonna let you go, Brian, because I am looking for debates. But hopefully that helped clear things up.
Yeah,
Probably not.
It was a slight. It was slightly helpful. I'm personally committed to like the Humean account of laws, but maybe there's some other account with like the definition.
I'm sympathetic to the view. I'm not sure I'm committed to the Humean account of laws. I am sympathetic to it though. So I can understand why you would be.
Yeah.
All right, but thanks for being here, Brian. Take care.
Yeah.
That's the most good faith anime profile picture that I've ever seen. Not to essentialize anybody, but from Joe with the 729 Arab Emirate dirhams, if the Abrahamic God was proven, would you worship him? If he is as described in the various Abrahamic texts, no, dude's an asshole. And from Odd Mod with the 10 pounds, a little support for everyone's favorite physicist. Thanks, Dr. Blitz, and if you need extra YouTube chat mod, let me know. Fair enough. Well, if you want to apply, you always can. There's ways to do it in the Discord chat. You can apply with our admin. All right, let's bring up Interesting Void 66. Interesting Void 66, you're on the show. Interesting Void.
Hello, can you hear me?
Yeah, I can.
Perfect, okay. So, can you hear me? Hello?
Yeah, I can hear you.
Perfect, okay.
Go ahead. You were saying something?
Sorry, I had you pulled up on something else, so I think it was the voice was looping back.
Ah, okay. Yeah, so hopefully you can hear me now. So, Interesting Void, do you believe in God?
Yes, I'm a monist.
Okay. Well, you can be a monist and not believe in God, right?
You're right, but I think that there's some good evidence that Jesus is who he claims to be in the Gospels.
Okay, that's a different claim than just being a monist. So, like, you're a Christian. A Christian monist, perhaps, but a Christian. Okay,
yes,
so
exactly.
Why should I think that the God that you believe in is real? I mean, you said that there's good evidence, so we could just talk about that if you want.
Yeah, so I think the best support is actually the historical evidence
Like
that
what?
Jesus, in fact, so most biblical scholars and experts agree that Jesus died by Roman crucifixion.
Yeah, I can believe that.
That he was buried in a tomb, that tomb was later found empty.
That I'm not so sure of.
Well, we have to go by the experts.
I don't think that the experts all agree that the tomb was found empty. I've heard people make this claim that there's expert consensus behind it, but I've never actually seen the evidence for that. And in fact, I've seen experts or people who, seem to be experts anyway, who say otherwise. So, I mean, we could just Google this. Is there like a survey that you're referring to?
Well, I'm referring to Gary Habermas.
Oh, Gary Habermas doesn't actually support his positions with expert consensus.
Well, he believes that 75%, or he says that 75% of scholars believe that the tomb of Jesus was found empty.
Yeah, so it's incorrect. The claim is 75% of papers in any field that, the things that he sampled make that claim. But this is not the same as scholars, and these are not the same as, theologians or historians, right? He was examining theological papers as much as he was examining historical papers. So, like, the sourcing for his claim is kind of a bait and switch.
Well, can we agree that at least that Jesus was buried in a tomb?
I think that it's a possibility. It certainly wasn't standard, but Jesus may have been a special case, so they may have buried him in a tomb.
All right, and then can we agree that his disciples had physical appearances of Jesus shortly after his death?
I don't think that happened. If I did, I'd be a Christian.
Well, once again, this is the belief that most scholars have. After all, how did the religion start in the first place if they did not have...
Well, so to be clear, you made the claim that they had physical appearances, right? I don't think that there were physical appearances.
I understand that you may believe that they're not, but what I'm saying...
They could have hallucinated, for example. I'm not saying that is what happened, but that's physically possible, right?
The problem with the idea of physical hallucinations is that
no, they're not physical. If they're hallucinations, they're not physical.
Of course, but what I'm saying is hallucinations in both a sensational way and a visual way. If that kind of makes sense.
I'm not sure that happened. I mean, like in the case of Paul, right? Paul saw a bright light, and then he heard a voice, right? So there's no physical sensation there.
Well, there was certainly some sort of physical. Well, they believed that Jesus
appeared
to them.
At least some of them did. How many of them is a
Okay.
different story, but
And
at least
so-
some of them did.
Well, at least 500. If we go
Well,
by
no,
the
that's a
earliest
claim. That's a
evidence.
claim that we can't justify at all.
Well, the early evidence that we have is that most of the disciples physically saw or somehow think they saw Jesus, and that 500 people shortly after that.
Well, that we don't have.
shortly
To be
saw
clear,
Jesus.
we don't have any evidence that these 500 people even existed. And the scant evidence we have for any of the disciples claiming that they saw it is just what's written in the Gospels, and that's it. And then some later texts as well, but like primarily just the Gospels. So like there's not actually historical evidence here. At best, you have like a few texts that are, you might say, ideologically biased, and those texts don't even get us to. I don't even think they get us to the line of plausibility.
Well, it's interesting you bring up the Gospels. Now, I understand that you say they're ideologically biased, but these are accounts, right, from the disciples. And like the Gospel of Mark, for
Well, that's the
instance.
claim. We don't know if that's true.
Well, we know it's true.
In fact, I think.
because there is-
And I could be wrong here, but isn't only one of the gospel accounts written by one of the 12 disciples?
Yeah, that's the Gospel of John. But you got to remember the Gospel.
Yeah, so the
of
rest
Mark,
weren't even claimed to have been written by
Mark-
disciples.
Well, you may be misunderstanding how the Gospel of Mark
Oh,
was thought to be
and
written
Matthew.
down.
And Matthew.
So, of course, Matthew as well. But you got to remember that the Gospel of Mark was Peter's interpreter, right? So he wrote down what Peter was telling him, and Peter was one.
Well, that's the claim. We don't know who wrote the Gospel of Mark.
Well, we know that it was Peter's account from written down by Mark, if that makes sense.
We don't know that. How would we know that?
Well, because like early church fathers cites Mark as the interpreter of Peter and him writing down what Peter
Yep, that's the tradition.
has told him into the Gospels.
That's the tradition, yeah.
Yes, that is the tradition. But because that's the tradition, and because of how early it is, it's not just like something somebody's made up, right? If
What's
this
the
is happening,
and maybe you know better than I do. What is the earliest attestation that the Gospel of Mark actually is written by a guy named Mark, summarizing the story or describing the story of John? Do you know off the top of your head?
Okay. So that's going to be the church father known as Papias, right? And he's writing in the 120s.
So we have writing from Papias. I'm just checking you because I just want to make sure. So we have writing from Papias describing the Gospel of Mark.
Yes, and specifically how it was written down.
Okay, so we have Papias who. I guess we have Papias of Hierapolis, and correct me if I'm wrong. I'm just reading a summary because this could always be wrong. And it says it was preserved by Eusebius, described Mark as the interpreter of Peter. Is that in line with your position?
Yes.
Okay.
Yes.
So,
exactly.
Okay, so this is like minimum at least a generation afterwards, right? By the time he's doing this, so it depends on when you think Mark lived. But Papias was a bishop. I guess he lived between 60 and 130 CE, approximately anyway. And so, he certainly wouldn't have been a bishop before, 100 CE, say. And that would have been at least a generation after Mark was written.
If you mean like a generation, you're probably talking like 20 years.
Yeah, 25 years.
You got to remember that but you got to remember that there were records of these things.
Well,
so he's not
that we know of.
Well, Papias had the church records, right? He had the Gospels themselves.
What records was he referring to?
The records of his church, in the church. So based
wait a minute. So we don't even have Papias's texts. We have what Eusebius said Papias said.
Well, we don't have any original text of anything. I mean,
we don't even
need
have copies of
obviously-
his text. We just have that Eusebius from the 4th century said, and this is what Papias says about Matthew. And so Matthew composed the sayings in the Hebrew tongue, and each one interpreted or translated to them to the best of his ability. So like, that's like a third. That's a 4th century statement about what a about what a 2nd century bishop said about what a like. You see how like the chain gets longer and longer.
The chain does get longer, but the problem is, how do we know that anything is accurate, right?
We use
need to go by
archaeological
the
data.
copy.
That's what we do. We use archaeological data. When we're not sure about the authenticity, when we're not sure about the how truthful claims were in ancient texts, we rely on archaeological data. So, for example, you can go find, and I can find examples of this. You can go find examples of like various descriptions of battles where there's like, and there were 500,000 men fighting against the 5 million men of the blah 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 empire. And our 500,000 man strong army defeated. And then you go look at the archaeological record, you find the battle site, and it was like 2,000 guys. So like when something is suspicious is probably not the right word, but when something is, seems a little bit far-fetched, we go and we look up the archaeological record to see if we can corroborate the claim.
The problem with this idea that these stories were just invented and not truthfully witnessed is that these disciples died for what they believed in, right? And they wouldn't die for something that they invented.
How do you know?
How do I know what?
That they died for what they believed in. That they refused to recant, and they died because they couldn't reject the true thing that they saw. How do you know? I mean, how do you know that they died? How do you know that they were executed in the first place? Some of them we know that, I think 2 of them we know that they were executed, but the rest are kind of just stories. And then how do we know, of the ones that we know were executed, how do you know that they had the chance to recant, that they were being executed for their beliefs, not because of something else that they did? None of this, all of this is just tradition, right? It's just like what the church fathers say, but we don't have any evidence that this is the case.
Well, historians do generally agree that Peter died under Nero's persecution, right?
Yeah, I think we have Peter and James are the 2 that we have good reason to think actually were executed.
Yeah, so Peter and Paul were executed in Rome, and James, I believe, was executed in Jerusalem.
So yeah, we have James, and so we have James and Peter. Those are the ones that we have external sources for. About their execution, and then I guess Paul wasn't one of the 12 apostles, one of the 12 disciples, right? So, but yeah, I guess also Paul. We have some evidence, although it's not particularly direct or contemporaneous evidence that we have. So we have like 2, maybe we have like 2 of the 12, or maybe 3 of the 13, if you will, that they were executed.
And of course, other disciples as well were also martyred at various points in time.
We have like tradition that says that, but we don't really have like actual evidence, right?
Well, but in the same vein that we know that Paul, James, Peter were executed, we can also infer that the other disciples were executed.
Why can we infer
sources,
that?
Right?
Well, no, they're different sources, right?
Okay, well, just sticking with those 3 then, if we can agree on
okay.
that.
So now, if I remember correctly, if I'm remembering my my biblical history correctly, with regards to James, he was executed because he was hot-headed, I believe is what it says. So I think, if I'm remembering correctly, again, and I think that this is the one that's in who wrote about this?
Josephus, I believe.
Is it Josephus that wrote about it? It might be, because I think that that's the one where it says, yes. Oh wait, this is the wrong. it's like, yeah, he's so hot-headed, and you know, he's whatever. Oh yeah. So it's Josephus. It's Antiquities of the Jews, book 20, chapter 9. We can pull it up specifically. Book 20, chapter 9. Let's pull it up and look just to make sure that I'm not misremembering. Okay, so we have the Antiquities of the Jews here, written by Josephus. And I don't think that this is the one that's like called into question its veracity, but I think that this is the one. We want to go find, oops. We want to find James. Yeah, okay, here it is. Festus was now dead, and Albinus was but upon the road, so he assembled the Sanhedrin of judges and brought before them the brother of Jesus, who was called Christ, whose name was James, and some others, or some of his companions. And when he had formed an accusation against them as breakers of the law, he delivered them to be stoned. But for those who seemed most equitable of the citizens, and such as were the most uneasy at the breach of the laws, they disliked what was done. They also sent to the king Agrippa, desiring him to send to Ananias that he should act so no more for what. Okay, no, I was thinking of a different executed person. But here, I guess the accusation is that they broke the law, not for just having a belief.
But what is the law that was broken, right? It was this claim that Jesus was the Messiah.
Where is that?
Was God.
What evidence do we have that that was a law? Why would they have a law against claiming Jesus was the Messiah?
Why was Jesus executed? Jesus was executed because
for fomenting political unrest. That's why he was assembling groups of people that were following him around, and he was like, talking at people and giving speeches and being disorderly.
Well, how exactly was he being disorderly? By claiming to be the Messiah, right?
Yeah, so if you're causing disorder, then yeah, that's breaking the law. Doesn't matter why you're causing disorder.
Exactly. So the disorder would be like what we're calling breaking the law is actually claiming to be the Messiah, right? And gathering.
No, the breaking the law. Look,
right?
Okay, so I can perhaps. No, I'm sorry. It was James that was executed for breaking the law. Apparently, he was called Sons of Thunder due to their hot-headed nature. So I was right about this. It just doesn't describe it in Josephus. But anyway, so let's say that I am let's say that I claim to be God, right? Let's say that I claim to be God, and I start assembling a following in the United States, and eventually hundreds of people are following me around, causing unrest. People aren't paying attention to the police when the police are telling them to disperse because they're so captivated by me. And so, then I'm arrested for causing social unrest. Was I arrested because I was claiming to be God? No, I was arrested because I was causing civil unrest.
But why was he causing civil unrest? It was because he claimed to be God. And then after he was executed, his followers never stopped believing that.
Okay.
So like most messianic claimants in the first century, right? After their deaths, their followers would disperse. Their followers would no longer believe they were the Messiah, right? Because
I don't know if that's true.
The Messiah was not.
Can you give me examples?
I'm pretty sure that most scholars, and I could pull.
Can you just give me an example of the name? Because there's a fellow. In fact, I think that this was like a Roman thing. There's a fellow named it was actually Nero that had people follow. Like there were people that followed Nero after his death, and then were tricked by an imposter who claimed to be Nero Return, and then they went to battle with him. This is like a thing.
That's Roman. That's not.
Yeah.
That's not in Judea.
Judea was part of Rome.
Yeah. So. Yes, but the Jews were of a special status or class, if that makes sense. Like they were technically under the purview of Rome, but they were not being conquered by Rome until much later, until like the fall of the temple, right?
They were a province of Rome. They were a province.
Yes,
so like I don't know what you mean that they were not like conquered.
Okay, so
pretty sure they were.
So do you know about the temple's destructions in 70?
Yep.
Right.
Very familiar.
Okay.
Yep.
So that.
Rest
Exactly.
in peace.
So that was. So that was when the Romans completely subjugated the Jewish people, right?
Yep.
Before that, the Sanhedrin still had political power, right? So the Jewish
Rome did that. Rome did that kind of thing quite frequently, where they like used like the local government as their arm.
Exactly, but the local government in other cases would have to adhere to Roman religion and Roman law.
No,
Well,
they
in the
didn't.
case of the
No, Rome
Sanhedrin,
didn't.
they could
Rome
still-
never enforced religious traditions. It was never a thing.
Well, yes, because that's why the Christians later would be executed, because they were no longer under this Jewish exemption. So the Jews had an exemption to worship their own God and
This was like
worship the Roman
standard.
God.
Like having like the whole thing about Rome is that the reason why they were so successful and the reason why there weren't a whole lot of uprisings was because they didn't really change the way that people lived. They just levied taxes. They didn't force people to accept a religion. This is ahistorical.
No, you had to worship the emperor at the very least and the Roman pantheon. It was thought that was
No,
going
you
to
didn't.
uphold the empire's order.
Where's the source for this claim?
Sorry, let me try to. I thought you'd agree with me on this, because obviously we know that
No.
Christians were executed for claiming that Jesus was God and they would refuse to worship other gods. Is this so? You do not believe that any Christians were executed?
Christians were executed later. Christians were executed later because they were, they would be taken as slaves sometimes, depending on, like there were like Christians that were eaten by lions, right? That was definitely a thing. Now, as for the reason why, it's very possible that they just didn't like Christians.
Here we go. So
because keep in mind, there were still Jews,
Roman
right? There were still Jews that weren't like fed to lions. So like, why would they exclusively feed? Well, okay, I think probably some Jews were, but like, you see what I'm getting at?
Let me pull up the Jewish exemption from Roman religion.
Okay, sure.
So Jews were legally exempt.
And what's this
from worshiping the Roman. Let's see. Teach democracy. Civic participation begins with civic education. Let's see. Teachdemocracy.org. So it's trustworthy, right? It starts with or ends with org. This is agreed on by historians. I don't know why you're disputing this.
Because I think that this was pretty standard. That like people were generally just were allowed to believe whatever they believed. There wasn't like some law.
All right, so in 63 BC, the Romans
Rome was super syncretic. That was like their whole shtick.
They were syncretic, yes, but you still had to pay homage to the Roman emperor, because you got to remember that religion and politics was not separated.
Yeah.
Then,
So
like it is now.
sure.
So,
and do you think
so
think that the Jews didn't respect the Roman Empire? Didn't respect the Roman emperor?
They had a special exemption. Like look it up yourself. I assure you.
Okay,
the Jews had a special exemption. Okay, thank you. The Jews had a special exemption. All right, look up the Jewish exemption from Roman religion.
Okay. Religio licita is a phrase used in the Apologeticum of Tertullian to describe the legal toleration of Christians. It was not an official term in Roman law. Oh. Okay, that's weird. Religio litica has sometimes been taken as a formal recognition or charter, originating with Julius Caesar and embodied by various pieces of Roman legislation pertaining to the Jews, conceived of as a coherent policy. In fact, the various privileges and exemptions granted to the Jews were responses to specific complaints or requests made in the context of the traditional patronage network, and had nothing to do with the supposed religio litica or licita status. To the extent that the Romans respected Judaism, it was because of the religion's great antiquity, ancestral tradition being regarded as a source of social and political stability. It has been observed that Roman magistrates treated the Jews the way they did not because they were consciously tolerant, but simply because they had no reason to hinder the free exercise of Jewish religious practices. So it doesn't actually sound like this was a law. It was just like they just let it happen. And apparently they did the same thing with the Christians later.
Well, the Christians later. Well, the reason that the Christians were no longer under the Jewish exemption was because they distinguished themselves as Christians, which is why they were put to death. And
but it doesn't look like this was actually like a law. There wasn't like some official Jewish exemption. It was like there were various privileges and exemptions granted to Jews because they complained about stuff. They were apparently part of the traditional patronage network and didn't have anything to do with like a special status.
What website are you?
That's Wikipedia.
Wikipedia. Okay.
Yeah, just look up Religio Litica or Licita.
I'm on a different website, but let's see. Wait, what did you say it was called again?
Wikipedia.
No, that term you were using.
Religio Licita. The Latin word that Tertullian coined, I guess. It was not an official term in Roman law, famously. It was also written about.
Oh, okay. Yes, this is.
Yeah.
This is about the legal toleration of Christians. Okay.
Well, scroll down to Judaism as Licita. Scroll down to that section. Oops.
Yeah. So it was not. This was not a term that was used to describe the Jews. No. Let's see if we can find.
Scroll down to the Jewish section. It specifically talks about the various privileges and exemptions were responses to specific complaints or requests made in the context of the traditional patronage network, and had nothing to do with the supposed Religio Licita status. I don't know why I can't talk. It wasn't like some official status. There were just some stuff some exemptions and like privileges that were granted because people complained about stuff, and like that's the kind of thing that would happen everywhere.
The exemption was that you did not have to worship the emperor.
Yeah, because people complained.
You could exclusively worship the monotheist Jewish God, and you did not have to worship the Roman gods.
Well, that's not what it says here, but we can go keep looking.
That was the privileges and exemptions that were granted to the Jews. That is the Jewish exemption.
Well, let's keep reading then.
Up until 70 AD.
Let's keep reading. Usually Judaism is regarded as a religio licita of the Roman Empire. Nonetheless, it is always regarded with suspicion, as can be detected from Menachem Stern's collection of ancient anti-Jewish texts. Edition. Okay, this is
All right,
fine,
so
but
it looks like it was
not really going
recorded
over
by
the details.
Josephus. It looks like it was recorded by Josephus that Jews were granted specific legal carve-outs.
Yeah, exemptions, privileges, because they complained.
Yes, exemptions.
But this is not unique to Jews, right? This was apparently within the so-called patronage network.
This was pretty okay. This was pretty unique to Jews, because Jews were the only monotheists that were conquered by the Romans. Everybody else did not have the ancient texts, the backing that the Jews did. So the Jews had their.
Is this true?
Their monotheist
Let's look this up.
religion.
It might be true that they were the only monotheistic religion at the time that was available at the time. But there were other monotheists in the area. The Romans may have just not gone so far. Because like there were the Zoroastrians in Persia, but I don't think that the Roman Empire extended that far, right? So that's possible. It's possible that the Jews were the only monotheists in the Roman Empire. That's true.
Yes. So
but it wasn't because they were monotheist. It was because they were old.
Yes, correct. That is correct. Because Rome believed that anything that was old had superiority, essentially. So they allowed this exemption.
Bunch of weebs.
Okay, so we can agree on that. Okay. So what I'm trying to say is that the Sanhedrin, or the Jewish government, had authority over Judea during the relevant time period.
They had religious authority. Well, but look, so this thing called the patronage network is this idea that it's what you're talking about, right? It was like the idea between like you have Rome as like the central governing body, but then you have all these conquered places which have their own governing bodies, and those governing bodies kind of rule over their local area, and they just kind of like owe stuff back to Rome.
Exactly. Yeah, that's a good way to put it.
And so the Sanhedrin, or in the, I mean, they also had a king, was in this case, in Judea, was like the governing body.
That's correct. Yes, and so
this isn't unusual.
The Sanhedrin implemented. That is not unusual. The exemption for worshiping the Jewish God exclusively and not the other gods is, but I don't think any of that's important actually to this argument.
Okay, if it's not important, then that's fine.
All right. So we can agree that there was the Jewish government at the time, the Sanhedrin, right? And that they executed Jesus because he claimed to be God, right?
No, we don't know that that's why they executed Jesus. In fact, it's not even agreed upon by all scholars that he even claimed to be God.
Or claimed to be the Messiah, right? So he claimed to be the Messiah, and it is basically supported by most of the evidence that that is why he was put to death. I mean, you recognize he was executed.
What's the evidence?
You recognize that he was. Do you not agree that Jesus was executed for claiming to be, quote, the king of the Jews?
I suspect he was executed for being a political problem.
That's not what. Okay, well, political. Yes, you're right that a Messiah would be considered a political rival. But what kind of political problem was he? He was challenging the
authority of the Jewish rulers.
Exactly. He was challenging the authority of the Jewish rulers but you have to remember, back in this day, politics and religion were almost one and the same.
Obviously they're closely related. The point is
yes,
it's not clear to me that like they executed him because he was the Messiah. It seems more likely that they executed him because he was becoming a political problem.
Because
and
he claimed
the
to
reason
be the Messiah.
why he was becoming a political problem was religious in nature. But it was the political, like if he was just like holding like meetings in his home and wasn't like organizing large groups of people and like turning over tables at the temple, if he wasn't like being a political problem, he wouldn't have been executed.
Right. If he wasn't going around publicly claiming to be the Messiah.
It wasn't publicly claiming to be the Messiah that was the problem. It was the being a problem, assembling large crowds, causing unrest in the temple. Right? Like it's not just words that he said, right? That's not all Jesus did.
What on the cross, what was the claim that he was being mocked for? That he was calling himself
that the Romans put up there? King of the Jews.
Exactly. And why did they think he was calling himself the King of the Jews? It's because that's what Messiah
No, I think that they were making fun of him.
Yes, they were making fun of him. But why were they making fun of him? Because he was claiming to be the Messiah, which would be equivalent to essentially claiming to be King of the Jews.
That's a good point. Okay. The Messiah is supposed to be a literal physical king, right?
The Jews at that time believed that the Messiah would be a physical human king. And so that's what it says
in the book, right?
Well, actually,
the Hebrew scripture.
This is actually a big point. Is that most of that's what the Jews thought at the time, right?
So was the scripture wrong?
So all of the Messiah. No, what? So most
the scripture. That's what the scripture indicates, right?
That's how the Jews at the time thought.
That's what the Jewish scripture says, right?
The Jews were not known for interpreting scripture very well. In fact, most of
it's their scripture. What do you mean they're not? No, they wrote it.
The Jews were constantly going against God's commandments. They were constantly disobeying God's orders. I mean, just all throughout the Old Testament.
Yeah, that's the story.
Correct. So the Messianic claimants of the first century, right? And I have a list of them right here if you want me to read them off. But they all claimed to be the Messiah.
Yeah, can you give me a few?
And then they were put to death, right? All right, let's see. We got Judas the Galilean. Led an armed resistance against the Romans. All right, so
wait. So actually, can you finish that? Can you finish that sentence?
led an armed resistance against Romans.
And then what?
Census under Aurelius, founding a philosophical/political movement that Josephus labeled the Fourth Philosophy, which was a precursor to the Zealots.
Okay, and then what happened?
Throngus. Oh, that's the extent of what I can read.
It sounds like you're telling me that he was a precursor to the Zealots, so it sounds like that they actually didn't stop following him.
They didn't think he was the Messiah, though. The Zealots were a certain subsection of Jews who believed
and you don't think that, and you think that Jesus was
the
the Son of God now. You don't think he was just the Messiah. So, like...
That's because after his death, right, his followers were still able to recognize him as the Messiah. That does not happen, right? That does not happen unless something crazy, something amazing, something miraculous happens that makes his followers believe that he actually is the Messiah even after his death. Because think about it. If the Messiah dies, that proves he's not the Messiah, right? So the movement should disperse. And yet, the movement survived and thrived. Why is that? It's because of a very special event we call the resurrection, right? That is the main event of Christianity.
Wait a minute. I'm just reading this now. So Josephus doesn't tell us about the death of Judas of Galilee. But apparently Judas's sons were executed by the Romans. Why were Judas's sons executed?
Why were I do not know. Why were the sons executed?
Well, I mean, I don't know. It could be because they were saying that their dad was the Messiah.
If you can find evidence,
we don't know why,
of any other messianic claimant of the first century whose followers claimed he was the Messiah after his death besides Jesus, that would be...
Well, what about the followers of Nero?
Very surprising.
The ones who followed Nero, who followed an imposter because they thought that Nero had returned to life from death, and they followed him into battle.
That's not a Messiah. A Messiah is...
Romans didn't have this idea of a Messiah, but it's the same thing.
Correct.
It's a returned king here to rule the world. Like, it's the same thing.
He's not Jewish. He's not the Messiah. It's not based off of the scripture.
So what? You asked me for an example. This is a perfect example.
I was looking for an example of a Jewish messianic claimant whose followers believed they were the Messiah even after their deaths.
Just to be clear,
that is exclusive to Jesus.
Okay. You know what else? You know what's exclusive to Muhammad? He claimed that the moon was split in two. Okay. Does that make it special that he claimed that?
It's actually interesting you bring up Muhammad, and I think this is actually one of the things that a lot of people don't recognize about Christianity is that the evidence for Christianity is so much better than these other religions. So, for instance,
well, no, but my point is you brought up a thing that is perhaps you brought up a thing that's perhaps unique to Jesus. I brought up a thing that's perhaps unique to Muhammad.
Yes, but we have to take into account when this evidence came about, right? So the evidence that Jesus was resurrected from the dead is, written down mere decades after the fact, right? I mean, in fact, actually, I think Paul wrote his letters less than a decade after the fact. But while if you look at a claim that Muhammad made, right, claimed about Muhammad, I should say, these come 200 years after Muhammad supposedly lived, right? So these are not equivalent.
I think that we have better documentation of the Quran than we do of the Gospels.
The Quran, okay, number one, the Quran does not actually Muhammad.
Sorry, one more time, you cut out.
Stories. I said the Quran does not tell us much about Muhammad, actually. These come from the hadiths. Most of the stories of Muhammad.
That I'm aware of, but I'm talking about the things that Muhammad, like there's plenty of stuff about Muhammad in the Quran. Stories involving Muhammad, for example. Like there are plenty of those. Like the example that I gave of Muhammad, being present for when the moon was split in two, that's in the Quran.
Well, the hadiths were the actual stories about Muhammad, but
okay, I'm not talking about those. I'm talking about the Quran.
Okay, so in the Quran, it's mentioned in the Quran that he split the moon?
Well, no, it's mentioned in the Quran. So Muhammad says something like, you know, those who, like, you unbelievers, look, and then, like, I guess Allah hears that Muhammad is asking for a miracle, and then so Allah splits the moon in two for them to look at. Yes, that's in the Quran.
Wait, which surah is that?
Okay, one sec. Let me find it for you.
Okay.
54 verse 1, Surah Al-Qamar.
Wait, say that one more time?
Surah Al-Qamar, it's Surah 54.
Let's read it. I don't know if this is really relevant, but we can read it.
It's not really relevant. The point is that there's a lot of unique claims in the Quran. Unique claims about Muhammad, that Muhammad was spoken to by Gabriel. You find me another person who was spoken to by Gabriel whose religion has persisted for 1400 years. And, you know, like, it doesn't make it true.
The difference is when the evidence is from, right? So Muhammad's evidence comes hundreds of years after his...
No, I mean, the Quran is very well preserved from his actual life, yeah. Like, we have good reason to think that what we have is almost identical to what Muhammad's scribes wrote down. That's like the one thing that Islam has in its favor, that it has historical reliability. Or historical preservation, rather. Oh, shoot. I actually can't keep you on for that long. I have to bring my cat to a doctor's appointment. Soon.
Oh, that's all good. I think we've had a good conversation. So you've certainly given me a lot to think about, and hopefully at least a little bit to think about. Thank you for this friendly debate.
Of course. Take care.
All right. Have a good one.
Sorry to end the live so abruptly, everybody. I just have to write some stuff down, but because I definitely do have to go. I forgot that I have an appointment for my kitty cat. It's just a checkup. She'll be fine, but I did schedule it. So let me read some super chats and we'll call it a day. From I'm the Big Cheese with the $10, fine-tuning is an argument against classical theism because it imposes constraints and external dependencies on creating the universe, or life, which contradicts pure act and divine simplicity. That's true. That is a good critique, and it's a critique I make all the time. From Relax with Russell with the $5, Dr. Blitz, what about something like a type of thing with a disposition to exchange energy with one or more fields for definition of physical energy? That implies that energy is a thing that exists, which it isn't. From Gerain with the $20, absence of evidence isn't evidence of absence. In a forest, if I say a nuke went off yesterday but see trees, birds, and no radiation, that's evidence of absence. God would be more substantial than a nuke. No evidence, no God. Well, okay, sure, but it depends on like what you mean. But like, if there's evidence and then there's evidence and then like it is a little bit different, right? The point is like in that case, if there was a nuke, then there must have been this. But like, then it must be the case that, you know, the forest is obliterated. So that's not evidence of absence. That's that's not absence of evidence. That is evidence of absence, right? But like if it's just like, oh, a guy was, if I say a guy was here, and then you say, oh, well, he didn't write his name on the board, therefore he wasn't here. Like that's not evidence, right? From I'm the Big Cheese with the $10, many theists today claim to have a personal experience with Jesus. We don't know if this ancient cult attributed same sort of experiences as evidence of Jesus' resurrection. Paul never makes it clear. That's a fair point. And from Joe with the 18 AED, so you're not after truth then. If even with proof that he is real and heaven and hell is real, you still wouldn't worship him because he is an ass, you're arrogant. Well, no, I'm after truth. I would still be, if someone provided evidence that he was real, I would believe that he's real. The question of whether or not he deserves worship is a different question, right? That's not a question of truth. That's a question of values. From I'm the Big Cheese with the $5, Paul's letters, which predate Gospels, doesn't make it clear that the resurrection witness claims were physical. He talks about a spiritual body. Oh, that's interesting. From I'm the Big Cheese with the $2, there were Buddhists in the Roman Empire. Temples too. Oh, I didn't know. Well, okay, during that period, I don't know. And from Melissa Silvas with the $2, MAGA and Christ-like simply don't go together. That's a fair point. All right, y'all. Just got to double check one more thing. Wow. Okay. From Shay with the $100 from about 45 minutes ago for down payment contribution. Much appreciated, Shay. I do appreciate you. You're always wonderful and you always support me. So you're very appreciated. To get a big round of W's for Shay. And I'm just checking for other things just to make sure. And yeah, should end the live, I guess. Yeah, see you all at Ian's. I'll be listening.